Mi dice lei quando posso partire?
Siamo in diretta.
Good morning, everybody. I'm very pleased to welcome you all, participant and speaker, to the 3rd edition of the New Space Economy ExpoForum, organized by Fondazione Amaldi and Fiera Roma, which aims to paint the big picture of the new space economy quick evolution over the past year. Many things happened since last year, confirming the need for monitoring constantly the parameters that influence the phenomenon, attracting more private investment every year, and increasingly reaching a wider number of innovative companies and non-space users. We are hopefully reaching the end of a special period affected by COVID pandemic issue that prevented us to work like in the past. That is why also the 2021 edition has been built with a smart digital format and unfortunately cannot benefit of an exhibition area for meetings and networking presence. However, while the virtual platform evolved in highly friendly systems able to serve the new way of living, the confinement delivered an important lesson about the need to reinforce interaction and to foster collaboration at every level. For the space community, this transition has been perhaps easier and represented just an acceleration of a natural approach which categorizes space activities and more than ever space economy with 3 trends: innovation, contamination, and globalization. Space is ready today to serve as an accelerator for managing the societal needs and can anticipate the action in tackling global challenges, even complementing current initiative and capabilities. During the last month, the space sector has provided a key solution to some of the immediate challenges. Space manufacturers and agencies have actively contributed to response effort. Many industrial plans introduced technology transfer as a key asset for revenues. Space sector is then experiencing a significant mindshare growth. For one thing, the pandemic crisis created the foundation for forging new avenues in the space sector, due for sure to the acceleration of the adoption of digital products and artificial intelligence, but also due to an increased political focus on societal challenges such as sustainability and resilience. On the other hand, the rise of more scalable and innovative business models democratizing access to space sector and the effortless user's access to insightful outcomes from space data contributed to developing a more customer-oriented approach. However, the space industry is still vulnerable to economic shocks. Not only SME, who represent the majorities of actors in the space sector, larger space companies have also been facing difficulties and revenues reduction that pushed them to reduce risk, to concentrate activities, and inevitably eliminate smaller and younger providers that are the key source of innovation, employment, and economic growth. In this scenario, the role of private stakeholders, identifying the crucial potential of space investment for commercial exploitation, is needed to keep the business running and contributing to the economic growth. Space continues to attract private investment worldwide. We got a positive trend also in 2020. This trend is largely driven by few significant US investments. It is still not enough for a sustainable global space sector. The New Space Economy ExpoForum 2021 will focus on the drivers which lead to the institutional and private European involvement in new space, and will discuss what comes next by introducing a new potential non-European stakeholder in future initiative. The goal of this year is to discuss how the space sector can support the growth of a safe, resilient, and sustainable society. I am convinced that maximizing the exploitation of space investment will benefit the global space sector as well in the long run, if we will be able to grasp the opportunity offered by new space economy in transforming the space in an enable tool with positive impacts and spillover in the large pool of end users of global economy. Wishing you all An interesting and fruitful conference, I would like to conclude by expressing my sincere thanks to all the organizers, speakers, and participants for their effort and outstanding contribution to the success of the 2021 edition. Let the New Space Economy ExpoForum 2021 be the booster to provide a space solution for non-space users in a stronger and safer global society. And I want to thank you, leaving the floor to the chair of the scientific committee who organized the conference, the Professor Roberto Battiston. Please, Roberto.
Thank you, Maria Cristina. Thank you to everyone. It's a real pleasure to be here today for the third edition of the New Space Economy European ExpoForum. This initiative is growing year by year. For the second time, however, we had to organize it in a remote condition, but we took advantage of that by putting together an extraordinary group of speakers coming from all the world, from all the continent, to contribute to the themes of this year. Discussing among the international advisory panel to set up the program of the conference, it was relatively easy this year to focus on the urgency of issues that the society, both at European and international level, is addressing. The pandemic itself is a sign of that, but we are within even greater challenges from the climate challenge, from the challenge which is influencing the assets we have in space and on ground due to continuously changing extreme condition, extreme event. More in general, the need that society has to be resilient in addressing difficulties of today, to plan for the better future where those issues are addressed and solved. So this is the background which everybody of us is living through this period of time. And space in this context can be extremely beneficial. This was the topic that was at the focus of a high-level committee that ESA put together to address what else can be done on top of the current agenda, on top of the current programs, to make space as an accelerator for addressing solution to the problem of society. This indeed can be seen from various points of view. Some elements are already quite evident. The presence of satellite operating in space to observe the Earth in a different physical parameters. It is instrumental to monitor climate change, to monitor CO2 distribution, to monitor all the parameters which are needed to analyze carefully the behavior of the climate over a long period of time. This is already a tremendously important contribution from space in addressing the climate issue. In the future will become even more important because on top of the observation can be the monitoring that the implemented agreement decided in the various COP conference is really going to happen according to what has been agreed and specified. So is one step forward to more precise, more accurate, not only determination of how things are going, but where the pollutant, where the CO2, where the methane gases are being released, in which quantity and to which extent. This can be compared with the existing agreement and decision taken at international level. But there is more than that. This activity of space in addressing the climate change has to be stepped up because of the continuous presence of extreme event from the meteorology event. We remember last summer a terrible flood which hit the center and North Europe, from all kind of phenomena which is taking place quickly, like ice melting, the forest, equatorial forest burning, usage of land and sea resources, which are quickly degrading with time. There are plenty of phenomena where space can, in very timely and very effectively, very accurately provide information which helps society to be resilient against the various type of difficulties, challenges, extreme conditions which are taking place on a daily basis because of climate change. And this is calling for space to be accelerator for providing solution, and not only like a monitor for the current situation, but accelerator to provide more careful, more detailed, more information, which can be used timely by the government, by the decision-making bodies in taking at the right time the right decision. And finally, connected to those two is the issue of asset protection. A complex society like the one we live through cannot operate without a set of infrastructure, of network of connection, of services, which are making possible day by day in many areas very sophisticated information type of services, which are strongly based on the availability of space technologies. This is clearly an essential part of the whole picture because we need those infrastructure. We need those assets in space and on ground to operate our society, and defending and protecting those assets from natural and human-related challenges is part of the call that space and accelerator to provide solution is about. I mean, space has to be accelerating the way to protecting the infrastructure in space and on ground. It's part of this big scheme where space is acting as an accelerator. So these concepts have been adopted as the basis of the Matosinhos Manifesto, approved by ESA member state in Portugal the 19th of November. And we decided that this is exactly the themes that the current third edition of the New Space Economy European ExpoForum will address and discuss, from the opening session where the global themes are issued and discussed, to the specific session on climate resilience and asset protection and finance, which are going deeper into those themes to elaborate and discuss in detail what is going on, what can be done, examples where space is already accelerating solution, examples where space should be step up in order to make a viable and important contribution to solving and addressing this global problem. And so we were able to call around this conference the best experts and mind all over the world. And so I'm pretty sure that we will appreciate the quality of these sessions and these meetings, and you will bring home some interesting information over how space can act as an accelerator, and how this can improve and increase the investment and the support for these space technologies at the European level. I thank you so much for participating to this meeting. I thank so much the Amaldi Foundation for supporting that, the Italian Space Agency. In a moment, I will give the floor to the president of Italian Space Agency, Giorgio Saccoccia, which will introduce the opening session. And I wish you will enjoy this third edition of the New Space Economy ExpoForum. Thank you so much.
Yes, thank you, Roberto. Thanks a lot. And okay, introducing Giorgio Saccoccia, I want to say you that he speak from Cape Canaveral this morning because this night we have a successful launch of XFIP satellite, a satellite devoted to astrophysics, and developed in collaboration, developed by NASA in collaboration with the Italian Space Agency. So I leave the floor to Giorgio Saccoccia.
Welcome the opening of the third edition of the New Space Economy ExpoForum, a conference dedicated to discuss space economy, addressing at the same time the quick evolution of the space sector. As president of the Italian Space Agency, I consider of utmost importance to follow this evolution in order to monitor and address new opportunities and challenges in this important sector. TAS-I, the Italian Space Agency, is indeed fully committed in fostering the exploitation of the space infrastructure and services, and in contributing to the growth opportunities for both institutional and commercial users of space. Space is today, for sure, one of the most complete and powerful instruments in support of society, a driver for innovation, a boost for the creation of new, highly qualified work competences. With the aim to leverage and encourage socioeconomic benefits deriving from space activities in Italy, a space economy strategic plan has been defined at national level to invest on and use space system, products and applications, also in non-space markets, and push our industrial system towards the new space economy. The Italian Space Agency is committed to a wide range of activities at national, bilateral and multilateral level, and will support the growth of the national space sector, providing a proper frame for new activities and investment. Increasing national capability in the space field and fostering the development of new space activity is not only a short-term goal for us. Space economy is an enabler for responding to societal challenges and for contributing to a smart, sustainable growth. In this overall perspective, investments are important as well as policies. In line with that, 2021 brought unprecedented achievements and decisions, reinforcing the willingness of Italy to contribute to shape a renewed and strengthened path for space activities in Europe. Of course, both at the institutional and commercial level. Important financial institutional resources have been allocated to space activities to allow our country to play an increasingly important role in Europe and in an international context. We are convinced that space activities will be crucial to support a greener future for our planet. Italy has invested since the 90s in Earth observation systems such as the Cosmos SkyMed constellation, the Prisma satellite, giving also a major contribution to the Copernicus system. Thanks to this investment, we are and will be able to deliver essential services for coastal observation and surveillance, fire detection and prevention, natural disaster management, critical infrastructure monitoring, and so many other applications. A concrete contribution to a sustainable future, not simply a greener one, and of course, not only for Italy. With the involvement of also non-space stakeholders, new space economy plays an important role in the global roadmap for our future. The wide range of public and private actors successfully shaping the European space landscape call for efficient multilateral cooperation to create a more resilient, autonomous and innovative European space ecosystem and to tackle global challenges. Space investment and activities are flourishing in all directions, but particularly in the areas of downstream services. Earth observation-based data analytics are expected to increase dramatically worldwide and to make available key satellite data, fostering application and services not just for institutional and scientific purposes, but of course also for commercial uses. Europe can tackle tomorrow's scientific, societal, and business challenges faster and better thanks to space asset exploitations. It is possible also to elevate our ambition and accelerate use of space as an enabling platform for delivering innovative technologies, stronger cooperation, and cost-effective services. Let me conclude in congratulating the organizers of the New Space Economy ExpoForum for the excellent contents of the program of this year edition. The forum is a very attractive opportunity to discuss new projects and ideas to better understand the potential of a new dimension, also economic, of the activities related to space. In this sense, it is clear that the New Space Economy ExpoForum can contribute to defining and appreciating, not only for those involved in the sector, the importance of what we call the fourth dimension of space activities, the one we are experiencing nowadays. The colleagues of the Italian Space Agency and myself have, of course, actively supported these editions of the forum because we are conscious of the importance of representing and discussing the powerful potential of the space sector and the evolution that this sector is experiencing today. I would like to invite, in particular, the youngest generation to take advantage and inspiration from the discussion at the forum this year. I'm sure that they will be able to grasp the importance of the new space economy as a pillar of the evolution of the space sector to meet global challenges, serving as an effective instrument to build up a better future, their future. I would like to thank you all for the kind attention, and I really wish you everybody an interesting New Space Economy Forum 2021.
Good morning, everybody. We are starting the keynote session now. We have 9 very interesting speeches from important players of this field. So I want to limit myself only to a short introduction of the person that will speak first, Massimiliano Salini, that is member of the European Parliament in several important commissions, industry, international trade, and so on, but especially has been in 3 years ago, I think, reported for an important report to the European Parliament about new space economy, and is also vice president of the Sky and Space Intergroup in the European Parliament. So please, Honorable Massimiliano Salini, you have the floor.
Thank you so much. And thank you for inviting me again in an important meeting about the space economy, and starting from the new space program for which I was the rapporteur. And let me start from a very recent fact. You know very well that last week we successfully launched 2 new Galileo satellites, bringing the number of Galileo satellites to a total of 28, and again enabling more robust services and accurate signals across a range of industries. Let me say that as a rapporteur of the space program within the European Parliament, this is a very good news for me, because after the negotiation about the legal framework, now what we negotiated is happening already. And then for me, I'm really proud about that. Well, normally I repeat every time I repeat that when we speak about the EU integration and the EU successful policies, normally we talk about the Erasmus, we talk about the internal market, obviously, the CAP, for example, but too little we speak about the EU space program, EU space sector. And this is a big mistake, because the EU space program is the only that built an EU infrastructure. And as European Parliament, during the negotiation about the new space program, our priority was to defend this European infrastructure by setting a clear, comprehensive legal framework for each component of this important program. And again, I repeat, we had obviously two pillars in this negotiation, and I think that the result is good. First of all, money to play a real role as a protagonist in the world at global level. In this field, we need a good budget, and let me say that this was one of the most challenging goal for us, because during the dramatic 2020, we had, the big crisis of COVID-19, and we decided to have a new part of the MFF in our budget as European institution, introducing the Next Generation EU. And despite the cut, for this reason, we managed to obtain a good budget, and we obtain more or less 15 billions, for the space program, divided in different parts. And this budget is bigger than the one in the last MFF, and this is another good news. Second pillar, rules. You know that to manage this sector successfully, we need a clear and stable governance. And also this one was a very challenging goal, because we needed to have a good governance. We needed to create, we need a real, in one side, cooperation, and in other side, separation of tasks and roles, because in the space program, in this space challenge, we have two different kinds of actors involved. In one side, European institutions like European Commission and EUSPA agency, and in other side, with a strong link between them, the international organization such as ESA. And the governance is the consequence of a good cooperation and separation between competencies of these institutions, and a cooperation, solid and stable cooperation, as I said. Last but not least, we introduce in a strong way also another pillar, in my opinion: transparency and democratic control. And in this case, the most important role is for the European Parliament, involved in the governance in a particular way, but involved. Well, industrially speaking, during the negotiation, we noticed that, unfortunately, in the past, the downstream sector was not fully promoted in the space strategy, European space strategy. And for this reason, we made a clear focus on the downstream sector. Also, the European Court of Auditors made clear that many space services are still not fully deployed, and this is a really problematic consequence. We have a lot of resources that risk to get wasted if we don't create a real and strong bridge between our European space champions and our SMEs and startups. This is absolutely possible. First of all, because EU space services demonstrate to be the best at global level. Galileo and Copernicus, first of all, Galileo which is the most accurate satellite navigation system in the world now, and is crucial to create important services for our citizens, and the consequence of our new interest on downstream market is to create real benefit, concrete benefit for our citizens, for our society, and a new possibility for competitiveness, as I said, for our SMEs and startups. But you said also the real effective performance of Copernicus, in particular as a perfect tool to implement the Green Deal. Roberto Battiston spoke about CO2 monitoring, but not only CO2 monitoring. We have a lot of implications, very, very interesting for our old program like Galileo and Copernicus. But we have also new challenges in the space European strategy, and I very much like the proposal of the European Commission to create a new space component on secure connectivity. This is a very important challenge for us today, because this is a prerequisite to have a real secure connectivity. This is a prerequisite for home working, home learning, and a lot of services. Broadband connection is the new pillar of our new strategy in our recovery plan, European recovery plan. I hope also for our Italian recovery plan, to be resilient, as you said, to have a real strategic autonomy, and for security and so on. Obviously, as a rapporteur of the European Space Program within the European Parliament, I'm really interested to understand the governance of new program about secure connectivity, and also in particular how we can finance this new program, because we have to pay attention not to cut all the programs. This is an important pillar of future negotiation about that. Well, to conclude, I think that speaking with my Italian politician colleagues, watching what my government is doing nowadays in this important moment to restart and to have a real recovery plan, as I said. I think that our space industry is not just a jewel to preserve, but in this case we are speaking about an industrial opportunity to take. And I'm sure that now and in the future we will push to have this specific strategy, space strategy, at the core of our recovery strategy. I'm optimistic, but I'm sure that speaking together like today in this way, we can push again and in a perfect way to have a real political understanding on that and a real involvement of our citizens in this challenge. Thank you so much.
Thank you very much, Mr. Salini. Now it's a pleasure to introduce Rodrigo da Costa, that is Executive Director of the European Union Agency for Space Program, the so-called other side of the ESA. Formerly, the agency was the European CNES agency, and Rodrigo da Costa was in fact program manager of the Galileo services, the important European constellation. So please, Mr. da Costa, you have the floor.
Gentlemen, thank you for inviting me and EUSPA to be part of this year's New Space Economy Expo. It is a great forum to share experiences and insights around topics that concern our growing new space economy, and in particular, the significance of space in addressing pressing needs of our society. In 2021, Europe faced several challenges. Natural disasters struck many European regions, from north to south and from east to west. Wildfires swept the southern Mediterranean, namely Italy, southern France, and Greece. In Germany, Belgium, and Austria, the severe floods sadly took lives of our fellow European citizens, while causing immense financial losses to national economies, but also to our common EU economy. We also witnessed the unprecedented Cumbre Vieja volcanic eruption in Spain. Now, almost 2 years into the pandemic, entrepreneurial world saw paradigm shifts. Many businesses suffered difficulties indeed, but many more adjusted, reframed, and newly emerged, keeping the EU economy among the strongest and most resilient in the world. Notwithstanding the importance of other factors, development and implementation of digital technology and space-based services are taking the lead in sustainable growth. It turns out that thanks to European innovation capacities, the more we are pressured by these challenges, the faster our technology advances. 2021 was a year of leap for the EU space in terms of policy and technology. The European Union now has a comprehensive space policy framework. The EU space program is now a reality. Made by civilians for civilians, the Union's space program is the result of unprecedented cooperation between legislators, space industry actors, and above all, EU member states. Consisting of 2 program components for satellite navigation, Galileo and EGNOS, one for Earth observation, Copernicus, the upcoming for secure governmental communications, GovSatcom, and activities in space situational awareness, among others, the EU space program is no longer a wishful thinking of tech engineers, business innovators, and visionaries. It is a robust platform that provides critical answers to all value chain actors. We are all, in one way or the other, beneficiaries of the services and products of EUSpace. As we speak, EUSpace is delivering on its promises. For example, earlier this week, another milestone for the world of EUSpace navigation was achieved with the launch of Galileo satellites 27 and 28 from the EUSpace port. More satellites equal better performance, more robustness, and greater precision. EUSPA, with its industrial team, is now managing the satellite operations to prepare for the integration of these satellites into the constellation. Synergies between Earth observation and navigation are key in the preparedness, responsiveness, recovery, and mitigation of natural disasters. In the unfortunate event of wildfires, for instance, it is important to have access to precise and up-to-date information for the delivery of an effective disaster management. Copernicus can map active fires, monitor their emissions, and prepare smoke forecasts. Those forecasts are used in air quality applications to help people limit their exposure to pollution and to help policymakers and local authorities to manage the impact of fires. EGNOS and Galileo support the response and recovery phase of disaster management by providing accurate and reliable positioning when rescue teams need guidance to reach affected areas, especially, and visibility is reduced due to fire, smoke, or fog. At sea, both Copernicus and Galileo are game changers in assisting local authorities to enforce existing regulations and measures, such as preventing vessels from remaining at a protected area for longer than necessary. Decoupling economic growth from resource extraction and environmental degradation is at the heart of the EU Green Deal. Turning to clean forms of energy, such as solar, wind, and tidal power, will enable the Union to curb emissions, transform Europe's energy mix, and thus reverse climate change. Green infrastructures, such as solar panels or wind turbines, are costly installations. They require monitoring to ensure their proper functioning and performance optimization. Often, natural hazards, such as landslides, can negatively affect the operations of these infrastructures. That's where EUSpace steps in. Satellite-based remote sensing feature of Copernicus is a cost-effective solution which keeps an eye on clean energy infrastructures, offering precious information on their integrity and targeted maintenance. Geospatial data by the EU's Earth observation system can also be used to enable more effective management of these assets by offering greater situational awareness and help mitigate risks such as vegetation encroachment on power grids and power turbines. In the sphere of energy, the concept of smart power grids is gaining more and more momentum. Electric utility companies are investing into them to reduce costs and optimize user experience and more efficiently manage their electrical power networks. Smart grid systems require precise timing and synchronization down to a nanosecond level, and GNSS clocks are used as a prime or backup source for time reference in case of outages. Ultra-precise clocks on board Galileo satellites can provide such accurate timing and synchronization information and thus make smart grids more robust. EU's flagship sat-nav systems also greatly contribute to Europe's sustainable mobility and urban planning. Galileo and EGNOS contribute to the rollout of sustainable transport modes by reducing aviation emissions and optimizing routes on land and at sea. Consider the following. Many of today's cars and trucks are already equipped with advanced driver assistance systems, including lane departure warning, automated braking, and adaptive cruise control. These systems are using Galileo to provide reliable, robust, and accurate positioning. Increasingly, transport services are operating in a cooperative environment with communication between drivers and road infrastructure. These cooperative intelligent transport systems will allow road users and traffic managers to share and use information. This is set to improve safety and reduce congestion by helping drivers to make the right decision based on real-time traffic situation. The use of satellite navigation systems, such as Galileo in road vehicles, can reduce journey times by more than 10%, and thus contribute to curbing emissions of harmful and polluting substances. The aviation sector creates 13.9% of the emissions from transport, making it the second biggest source of transport greenhouse gas emissions. By enabling aircraft to land safely under challenging weather conditions, such as fog, EGNOS helps reduce the frequency of aborted landings, so-called go-arounds, and therefore emissions. An estimated 80,000 flight delays and 20,000 diversions will be avoided, EU-wide, thanks to EGNOS by 2025. Population growth and urbanization are pushing the boundaries for resource usage and are creating a huge demand for civil infrastructures such as buildings, subways, train lines, bridges, dams, highways, and airports. According to our market report, by 2025, 83% of geomatics equipment used for cadastral surveying and construction applications will be GNSS enabled. As of today, more than 80% of newly manufactured geomatics equipment and instruments use Galileo. Both the construction sector and urban planning are directly benefiting from the EUSpace program, namely from the additional accuracy of Galileo and EGNOS, which allows surveyors to accurately pinpoint structures and reference points. What is more, Galileo and EGNOS-enabled drones can accurately and safely fly across points of interest and assess, for example, heat loss in buildings and facilities. EUSpace supports EU economy, generates jobs, optimizes business operations. Consider the following simple examples of space market penetration. The use of EGNOS is a win-win situation for both airlines and airports. On the one hand, it helps open up new commercial routes by making airports more accessible. And on the other, it helps airlines save fuels through route optimization and go-around avoidance. Think of agriculture and precision farming, where the synergetic use of the EUSpace program components, namely precise navigation offered by EGNOS and Galileo, and the imagery generated by Copernicus, enable farmers to increase crop yields, save on fertilizers, and save on water. The EUSpace industry employs more than 300,000 professionals, with 50,000 of them working in the European downstream market and generating an estimated 50 billion euro. The number of EUSpace jobs could possibly rise to 400,000 by 2025. Return on investment in space ratio within the EU economy is estimated on 1 to 10, certainly attractive for public and private investors. Protecting the EU citizens and ensuring the Union's autonomy and sovereignty is also a distinctive objective of the European Union space program. Copernicus contributes to the safety of citizens and security of regions by offering services such as near real-time fire detection and flood prevention. When time is of the essence, Galileo, its search and rescue service, with its pioneering return link, is providing one-of-a-kind safety feature recognized and appreciated by users. To contribute to the resilience of GNSS, EUSPA, together with the European Commission, is currently preparing the testing activities of the Galileo Open Service Navigation Message Authentication. This forthcoming service is an authentication mechanism that allows open service users to verify the authenticity of GNSS information, making sure that the data they receive is indeed from Galileo and has not been modified in any way. Authentication is set to further strengthen service robustness by increasing the capacity of detecting spoofing events. Dear participants, space is by nature everywhere and with a lot of applications. Its wise exploitation generates a positive spillover effect across many sectors of our society. As Executive Director of EUSPA, the user-oriented operational agency of the EUSpace program, I look forward to joining hands with all of you in striving to multiply the benefits of space and to place it at the service of citizens, governments, and our planet. Thank you.
Okay, thank you very much to Mr. Da Costa for your very interesting presentation, very complete. And now it is time of the Director General. We can say new Director General till the end of the year because it's been appointed this year. Josef Aschbacher, geophysicist by education, and that is in ESA from 31 years and has been in ESA headquarters, has been in ESPRA, has been in Esling as director of the Copernicus, sorry, not the director, but work at the sorry, Galileo, Copernicus Space Office, sorry, really sorry. And in ESA headquarters. Now we are very curious to hear from Josef Aschbacher. Please, you have the floor.
So thank you very much, and let me just say it's a great honor to speak to you. As you have mentioned before, I know Italy very well. I like Italy a lot, I have to say. I've spent many years of my career in Italy, in Frascati, but also in ISPRA. And I'm very happy to be invited for this presentation. So thank you also to Roberto and the organizers for this opportunity. What I would like to do is I have prepared a couple of slides which I wish to share with you. They are an update of what happens at the moment at the side of the European Space Agency, mostly from a programmatic point of view. I assume all of you are very familiar with ESA, but more recently we have had a very intense discussion and dialogue with our member states in order to define and detail where the activities of ESA, but also space in general in Europe, should be heading and what needs to be done. So if the operators could please load the slides and go to the second slide. Yes, thank you. So what you see here is the situation in economic terms. Of course, space has many dimensions, as you know, economic, strategic, societal dimensions. But in this case, you see on the left-hand side, the budgets which are allocated to space as share of GDP for different countries. On top, you see the United States, followed by Russia, Saudi Arabia, France, Japan. And then in yellow, you see the EU and ESA member states, the average of the allocation of space budgets as a share of GDP. And as you see, Europe as a whole spends about 1/4 of the space budget per head or per share of GDP, I should say, on space compared to the United States. And that's one fact. On the right-hand side, there's another graph which is quite remarkable. Here you see spacecraft launched in tons. Of course, this is a very crude measure because spacecraft are very sophisticated with a lot of electronics, software, very delicate instruments on board. But the weight still is an expression of how much space excellence or capability infrastructure is launched. And you see in yellow China, in green Russia, in red the United States, and the second box with a circle with a box around is Europe. Europe is much smaller, and this is really a fraction by a factor of 7 to 8 smaller compared to the others, and that's a fact again. So Europe launches much less spacecraft into space compared to the others. But if you compare, and this is not shown on the graph here, the GDP overall of Europe with the United States and with China, the European GDP overall is about the same. US is a bit higher, China, but Europe is very close. So it's a very similar magnitude of overall GDP of the economy. And it is quite surprising that in space we are much lower compared to our economic strength or our economic power, which we have. The next slide then shows what we have done about this. And this previous graph really outlines, and I've only shown the economic part of it. As I said, there are many other dimensions that are important for space. But this was really at the origin when I became Director General of ESA on the 1st of March to put a document on the table called Agenda 2025 to really wake up the community and make people realize what are the facts and what needs to be done in order to catch up and make sure that we are not losing ground. We have identified a number of priorities, how this should be done. You see on the right-hand side, ESA-EU relation, commercialization, safety, security, program challenges, ESA transformation. I will go into some of them a bit more in detail, but we have outlined a number of elements where we really need to engage in order to make sure that Europe is staying at the forefront. And one of the steps I did after the Agenda 25 was presented and, of course, agreed with the member states and the European Commission is to invite what I call 9 wise people who are very knowledgeable of space in Europe and who have been very actively involved at some stage in the business of ESA in defining space, but not right now. So they gives them a free voice. One of them is Professor Roberto Battiston. I'm really grateful for Roberto's strong contribution to this wise group people, because I have to say this group was working extremely well. Very, very good recommendations, but also a very intense working approach, which we had over 4 months. And the group then published a report, which is their recommendation to me as DG of ESA, what they think, based on today's trends and also the Agenda 2025, what should be done. And what this group recommended is to really focus space much more on the needs of society. So space is underutilized today, and therefore it needs to be reinforced and strengthened. And they recommended to do this through concrete action, and the concrete action we call accelerators and inspirators. And 3 accelerators and 2 inspirators have been proposed. And if you go to the next slide, please. So this is before I go into the accelerators. Just one point that was also highlighted is that commercialization is a key element in order to enable these accelerators and inspirators, and really to make sure that also in Europe we really change gear. We know that this is done very successfully in the United States. Companies like SpaceX, but also Blue Origin and many others are really profiting from an attitude which NASA and the public sector have done and have implemented in the United States in order to much stronger foster and develop the commercial market. And that's something we have to do in Europe as well. And I as DG of the European Space Agency have taken some action. I've proposed very concrete measures, what we want to do. You see a small list of them here. There are actually much larger number of them. But certainly we have also, among other things, to be much more of an anchor customer as a first buyer of services and data, rather than developing every single detail ourselves. Of course, we will still continue developing highly sophisticated spacecraft, but in addition, we have to strengthen and develop our role as anchor customer. You also see that we need to approach much more the financial world, venture capital and other funding entities, to bring the space startups, space companies much closer together with the financial world and make things happen in order to really ensure that capabilities can develop. The next slide then shows these accelerators and inspirators. They are Space for a Green Future, Rapid and Resilient Crisis Response, and Protection of European Space Assets as the three accelerators, and the two inspirators, IC Moon Sample Return and European Human Space Exploration. And I will explain them a little more in detail with the next slide, which says what are they doing and what's the concept. So they are not a classical ESA program as, for example, developing a Copernicus satellite. This is much more a combination of strength of different stakeholders in Europe, different countries, the European Commission, of course, also ESA, and bringing these assets together under joint objectives and a joint frame where we agree that this has to be done. So we have to respond to the urgent need of society, climate being one of them. We put the user at the center. Of course, we also want to strengthen the European leadership and STEM education, and very important, attract new funding sources. And this is crucial, because if you only put space money from one pot to another pot, or from the left pocket to the right pocket, we are not gaining anything. We need to really to make sure to talk to the user communities and see how space can help for climate in order to attract also funding from a community which so far has not been involved in the space community. And next slide. And this really is a very important step. What is the added value of the accelerators? And rather than going through the text on the left side, let me just take the analogy of the vaccines, which you see on the right-hand side. When COVID was hitting us, and Italy, and I've myself been in Italy in charge of ESRIN, the head of ESRIN at this time, it was a big disaster, and we have all been taken by surprise about the magnitude and severity of the COVID crisis. What Europe has done, Europe has really put its strengths together, and on the pharmaceutical side, developed a vaccine in record time. But this also was only possible because there has been over tens of years investments made by the public sector in pharmaceutical industry in order to develop vaccines in general. And the vaccine companies that have been successful have actually started not from ground level 0, but they have started from level 5 and then added one more floor in order to really come to the vaccines, what they have done. Fantastic job which was happening. But also what I want to say is that the baseline infrastructure, baseline research was funded through public entities over decades, and this really made it possible then to act very quickly, to have an urgency and act very quickly. And the same we have to do in the accelerators. We have climate change as an emergency. We have to act quickly, otherwise we are losing control of our planet. The next slide shows exactly this accelerator one, Space for a Green Future. You all understand the urgency, don't need to explain that. But what we will do is we build on existing capabilities like Copernicus, which was built up over 2 decades, and enrich them, enhance them, and really make sure that we are focusing on the needs of society, on creating a carbon-free economy, on net zero emissions by 2050, which are the political goals of Europe, but also outside Europe, actually worldwide. One element of doing it is to build digital twins of our planet, which is a combination of satellite observations, ground observations, Earth system models with artificial intelligence, machine learning, and high-performance computing on big computers to really simulate our planet. In short, we try to simulate our Earth on a computer. Of course, this sounds simple, but it's a very, very challenging task, as you know. And of course, it takes a long time in order to really achieve that. But we will work on this to have the possibility to have what-if scenarios to say, what happens if I change deforestation, if I change temperature increase by this level, if sea level rises are having this impact, but also what does it mean for people, not only for the environment, but what does it mean for people? What if desertification increases? Do people need to migrate? Or what are the first and most areas at risk, and so on? So this digital twin is really something that allows everyone, citizens, but also politicians, to really plan and make better decisions, again, to create this carbon-free economy, or carbon neutral economy, I should say, sorry, by 2050. And also green information factories will be needed. One particular technology is quantum gravimetry, which is quite exciting and helps a lot to better understand our planet. Next slide. So what is the cost of not doing anything? Sometimes people say, yes, you launch a new accelerator. It may be very exciting. That's what we need, but it costs a lot of money. Yes, of course, it costs money. This is obvious if you do things. But on the other side, you should ask yourself, what does it cost if I just don't do anything? I'm not saying that space can stop climate change. By no means, this is clear. But we can certainly help better understanding, making better decisions to limit its impact and to better plan for it and mitigate some of the actions. But in general, if we're not acting on climate change, these are the figures that are quoted not by space people, but by economists published here in Nature. What is the cost of just not acting on climate change, or acting, I would say, very moderately? And these are hundreds of trillions of dollars or euros, which the damage is. So I think it's clear we need to do something, and we need to do something quick. Next slide. Shows the accelerator number 2. Also, climate change is also creating disasters or enforcing disasters, making them stronger. Again, here, what this accelerator will look at is rapid and resilient crisis response, meaning to make sure that we use our satellites in combination with secure connectivity, which is also promoted by the Commission right now, Commissioner Breton, and that these two initiatives, hand in hand, can address, can provide quick information through constellations, through computing in space with cognitive cloud computing, and helping the firemen on the ground, helping the disaster management service on the ground with information which is quick, tailored, and securely delivered to these people. The next slide. Yes, of course, user is in the center. So this slide shows what is the cost of not accelerating. And what you see here is the number of disasters as they simply happen around the world. Flooding, fires, earthquakes, but many of them storms, many of them are caused by climate. And on the right-hand side, you see some figures of the damage. And you see immediately that these damages are huge. That means climate change is a reinforcing element of disasters and crises. And again, there's an urgency to act. Next slide. Number 3, the next accelerator, which is if we are so depending from our satellites in space, we need to protect them. We need to know where debris is. We need to fly maneuvers to avoid them. We need to possibly remove some of the debris from space. And here comes really space traffic management, but also collision avoidance as a core element of this accelerator. And on the right-hand side, you see space weather. Sun flares also threaten our assets, our satellites in orbit, also our astronauts in orbit, but also grids and their infrastructure on the ground. Again, we need a system to allow to estimate and warn people whenever such a sun flare element is coming. Next slide, please. Again, what's the cost of not acting or not accelerating? I don't need to explain to you that debris is becoming more and more of a problem. What you see here is the number of satellites that are being launched, close to 3,500 in this graph. Actually, today is even more. And this is a reality. We get more and more satellites in space. We have more than 3,000 satellites, actually, which are defunct, in addition to these active satellites, which you see on the graph. The defunct ones, of course, are the problem because they create debris. They may collide. They may even explode with fuel tanks that are heated up and therefore sometimes exploding. Some ASA tests recently have created additional debris. So this is an issue that we really have to address and where we have to do something. And that's why this accelerator is being proposed. The next slide. Then we have two inspirators, one on human space exploration. Of course, the big question is, does Europe want its own capability of flying its own astronauts to space? Yes or no? Today we are hitchhiking, riding with the US, with NASA. We also had astronauts flown by Russia. In the future, we don't know because, as you know, space travel also becomes more and more private. Do we want to go with a private operator there, or do we want to have our own capabilities? Because the next frontier of exploration certainly is still the space station or its successors on a commercial basis, and the moon, medium to long term. And there will be an economy developing, just like America was discovered 500 years ago. The moon is the next frontier. There will be economic activity. Of course, it takes decades, if not hundreds of years, to develop it. But the question is, does Europe want its own ship? That means its own rocket also to go there and have the capability of its own astronauts getting there. And of course, you can imagine what my answer is as the Director General of ESA. Yes, Europe needs this independence and this capability. Next slide. And this is an exciting one, which is more of a science-driven inspirator, which is an icy moon sample return. So biologists are saying if there is life outside our planet, then one likely place you should look for is on these icy moons around Saturn and Jupiter, because they are made of an ice crust, there's water underneath, and even if the life is very primitive, microbic or very primitive life, that could be there, and you should search there. So what the proposal is that to come with a satellite, land on such an icy moon. Of course, it takes about 10 years today to go there, just to give you a feeling of the distance. 10 years to go there, drill into the ice through the ice cover, get a probe from the ice of this moon, get up again into space, back to Earth, and through the atmosphere, down, land on our Earth atmosphere, and analyze what we found or what was brought back. Of course, this will not be for tomorrow. This will take a bit of time. But a lot of technology needs to develop to do that. But can you imagine the question of analyzing this probe, of what we will find? If we don't find life, any form of life, that's one answer, and certainly interesting enough. If we do find some sort of life, what is the DNA of this life? Similar DNA as we people or not, or completely different? And that, of course, raises a lot of other questions or gives answers to some of the burning questions of is there life out there? And I think this is so inspirational for many aspects, technology development, but also the very basic questions of the origin of life. I think this is something I really would like to propose as an inspirator to our decision makers. And with the next slide, please. Just to round it up and say that we have a few steps ahead in order to get there. A space summit is planned in Toulouse next year. ESA and EU member states will be invited by Monsieur Macron. Monsieur Macron himself will then conclude, at least that's the expectation today. But, and this is very important, the ESA Ministerial Conference is the occasion where funding proposals are put on the table for our member states in order to do the next steps. Of course, we have other ministerial conferences about every 3 years, but the one in November next year certainly is a key milestone. And with this, ladies and gentlemen, thank you very much.
Thank you very much, Mr. Aschbacher, for a very ambitious plan that we are developing. As an European, let me say that I'm very happy for this. I have also a small question, if I can, maybe a curiosity. Do you have in ESA somewhere enough computing power to develop an Earth twin, or are you thinking, planning something to have a new facility? Because it's very heavy as a project, very interesting. Anyway, if I can, as a chairman, it's not good, but I'm also a man, so please, I give you my congratulations for this plan. What about the facility, computing facility?
No, thank you. Thank you also for the very nice, positive comments. Today we don't have it, but it will be a combination of working with partners in Europe which have such supercomputers existing, but also in ESA right now, I am developing a plan to have some own capability, because it is clear that you also need your own computing of high performance computing in order to develop algorithms and to test and develop some of the models. So yes, we will use existing ones. There's actually a very strong one in Bologna, as you know, with whom we will link up. There are two supercomputing centers in Bologna. There's also one next to Frascati at INFN with whom we are working closely, but also others across Europe. So we'll certainly work with the existing ones. But yes, I'm in the process of also acquiring something within ESA, which of course takes a little bit of time. But this is certainly one of the challenges we need to face.
Okay, thank you very much indeed.
Thank you very much. Yeah.
Okay, now it is time to introduce Mr. Massimo Claudio Comparini, that is CEO of Thales Alenia Space in Italy and Senior Vice President of Thales, and is a well-known CEO, has been a well-known CEO for Egeo, in Rome, Telespazio, and so on. So please, Massimo Comparini, you have the floor, please.
Thank you. Thank you, Leopoldo, and it's really a pleasure to be with all of you in this important conference, which is now starting to be a kind of event to be. Let me share my screen, so I will go through the my presentation. Okay, Leopoldo, could you tell me if the slide is well presented?
Yeah, it is small, but we can read it. No problem.
Okay, so let's focus on the next 15-20 minutes to the contribution of the space technologies for what we call a sustainable economy, which is, of course, it's a more wide concept than just the economy per se. A sustainable planet, it's also our must, and I think it's extremely important that we show outside the space community how space technologies contribute to this challenge. It's a fact that in the last decades, space activities had a strategic content, and there is still a really strategic part, really strategic activity, and it's a fact that also through challenging missions, we open new technology frontiers in the space technologies. And just an example, scientific mission to explore in deep space environment, or to go to far planet like Saturn or Titan. You see the image of Cassini-Huygens was really extremely important to understand where we can go with those technologies. But in the last years, we observe as well that how those technologies are essential and key to develop new applications and new services for us as a citizens, for our communities, for the Earth. And starting from that, we have a kind of, as I will describe in a moment, a kind of new space economy or space economy momentum that is really attached to the kind of information that we can generate for our life on the Earth. And it's a combination. It's a combination of technology as well as new services, but it's also, if I could tell, the injection of a kind of faster product life cycle in the space asset and the new space asset generation. So more rapid momentum in the innovation to be injected in the space, lower cost, some commercially available technologies that can, at this stage, go to space, and a combination of breakthrough and incremental development. So this is the kind of ingredients that at the end generate in the last, let's say, 10 years, quite an incredible growing economy linked to space. And the basic element is to move from just a purely technology push industry to a really kind of user-driven. That it's simple to say, but has also a number of implications in how to design and how to build our space in infrastructures. And I will go in a moment also to think about what will be the combination of digital and space technology. So space today is really part of the so-called digital knowledge society. And it's a fact that the miniaturization of the space technologies, the capability to install also in a lower mass satellite different sensors make really change. At the same time, of course, also the performance of the high-class satellite make also kind of landmark on what we can generate from space for our planet. It's also true that having a more software-defined components, software-defined architectures, and a reconfigurable architecture give a new fuel to the architecture that we can conceive. And this is also part of a journey that, example, I mean, talking about, just after DG of ESA, just after Josef, it's remarkable what ESA is doing to push the artificial intelligence on the onboard technologies that for sure will give more and more feature to what we can conceive. So we have a number of architecture, a number of configuration. It's a fact that constellation and mega constellation make really a kind of driver in this evolution. But in general, we have a more and more cognitive and intelligent sensors on board. And this is across the domains. So we see global connectivity, global geospatial, so the capability to observe the Earth with a higher spatial resolution, but as well as with a much more temporal resolution. PNT, positioning, navigation, and timing. As you know, we started the concept of the Galileo second generation. And last but not least at all, exploration. We have in a new dimension also in the exploration field, and this is not completely detached also by the topic of sustainability on Earth. It could appear, but at the end, how we learn to live in other planets and how to use the scarce resources is also extremely important to build the sustainability on our planet. And so, as I said, is a fact that a kind of converging forces make the concept of the constellation very relevant in this evolution through technology advance, new business model. Why not more funding available also from private sectors? We see, for instance, the IPO of a number of space companies, and a greater demand, of course, for higher bandwidth and more data. So it's a fact that if we see the evolution in the next 10, 15 years, the majority of the number of assets to be deployed will be related to these systems of mega systems. And this is also posing some challenges and issues on the sustainability of the space per se, because of course, low Earth orbit is going to be crowded, more crowded than what we see today. And of course, the topic of the debris is something that we must absolutely address to make all of these still sustainable. So just a few words on the global connectivity. We know that what is the driver for broadband and for broadband evolution. So what is the connection in space? We are in connected as well as a hyper-connected world. And we see two elements. One, the evolution of the very large, very high throughput satellite, which is still something which is very important for the space industry, as well as the emerging of the constellation Omega constellation, as already said. So it's really also in this case we have a number of ingredients. The best use of the spectrum, of course, taking care of the best technologies and techniques to make that possible. How to conceive a sustainable, from a business plan perspective, a throughput of the large VHTS, as well as with the constellation, new constellation project. ISL, so the capability of those computing nodes or nodes of a network to communicate themselves, so inter-satellite link across the same orbital plane or across different orbital planes. It will be, and it is already, extremely important for the future of those systems. And last but not least, how to help and how to learn to manage those huge systems, those very large constellations, not only with the human control, but also with the help of advanced technologies and even artificial intelligence and learning feature in the management of those systems. Just a snapshot on the VHTS, because it's true that a lot of highlight on the constellation, but just to give an example, this is a picture of a last satellite that we produced that was for CES, and where, just to give you an idea, not technical elements, but just to have an idea, with the previous generation, we have a digital transparent processor that's scaling up a factor of 100, so 2 order of magnitude the overall capacity, just to think about what the technology today can give to us. As I said, for the exploration domain, I'm sure that at a certain point in time, maybe not in the close future, will be a multiplanetary humanity. But at the end, please don't forget that we have just one single planet. And at this stage, let's say, we need to protect our Earth. And so to do that, we need to address a number of challenges to build a sustainable planet, to understand the effectiveness of the remedies, and make that a kind of, let's say, challenge, address this challenge for our future generation. And it is a fact that the incredible progress on the Earth observation that we observe in the last 20 years is an extremely powerful instrument in this respect. So space is really the best place from where we can learn the most about the status, the evolution, the dynamic of our planet, and how to react to global changes. And I think that we need to be really proud, all of us as Europeans, because Copernicus showed to the world that what space technology can do. It's by far the most important Earth observation program, and is by far the most important program to generate this huge amount of data to start to address the challenge that I said, and that Josef before me clearly address as well. So through the Sentinels and through the evolution of the Copernicus program, I mean the first 6 Sentinels in orbit, the other 6 missions that the Commission and the European Space Agency plan to put in orbit, and you know that the European space industry and of course TAS already started the last year to work on those missions. We will really generate an incredible amount of space data, big space data, to generate the right information to address the challenge that I described. Of course, just to say a few words of role Thales in space, we're extremely proud that we are on board of 5 of the next 6 missions, leading 3 of them as a prime contractor, CHIME, CHIM, Roussel, but also with a very remarkable technology content on Crystal and CO2M. So just looking ahead, those are the 5 pictorial view of the next missions, and You may realize from the variety of the sensor, which is one of the very important elements to build up digital twins and digital twin Earth. From the variety of the sensors, we will have a variety of different data coming from instruments like, of course, space-based radar, micrometer, radiometer, altimeter, and that will help to have really the status of the health of the planet from the land, forest, the sea, the oceans, and of course the polar ices. Of course, as you know, as a company, we have also a long-standing legacy and experience on specific the radar technology, so how to observe the Earth from radar technologies with the full class of radar. And just to remember that we are going to launch in a few weeks from now the second satellite of Cosmos, second generation, which is a powerful constellation of space-based radar funded by the Italian Space Agency and the Italian Amaldi. Just few words on how the evolution of those infrastructures will generate, will push the services and application that I know also in this plenary will be addressed after my talk. You see on the left, you see, just to understand where we are, what is the prospect in the deployment of new constellations, new assets in the EO domain in the coming years, looking to the end of the decade, both optical, radar, and of course other sensors like hyper or multi or hyperspectral. At the same time, we observe how exponentially is growing the use of the free open data, for instance, from Copernicus. So we are in a point where, on one hand, in the coming years, we will have an exponential growing of the data generated from space, and we are already in a phase where the users really use an exponential growing amount of data. So this is, in my mind, is the best simple reflection to understand that we are not just in front of a simple evolution, linear evolution, but really an exponential revolution of how we can generate information from space. Information that is not anymore the picture, optical, radar, or other sensors, just a static image of the Earth, but is a continuous flow of information, is a continuous flow of insight of what's happening on the Earth on global scale, as well as on a very local scale. This is the beauty of those global systems. We can have the resolution that we know, in some cases also submetric resolution in a global scale, but the capability to address very specific local area, which is extremely important for a number of applications from agriculture to infrastructure monitoring. So I think it's clear from those few words how is essential the combination of digital technologies and space technologies. Is also through the capability to digest this huge amount of data, to compute, let's say, and to make accessible in cloud bases, so with the modern technologies, the information that we are going to extract from those huge amount of data, that we can really exploit all the potential of the space sensors that we will put in space, already here, but we will put in the space also in the coming years. And here, I think it's important just to recall all the momentum that the Commission and the European Space Agency put in this digital world. We know large programs like Destination Earth, Gaia-FE, the digital twin Earth that Josef just mentioned before. So this is really another part of our activity, how digital technologies are going to completely reshape our way to construct satellite, to construct space asset, as well as our way to use data and connectivity that is secure from those space infrastructure. And of course, like every company, TAS is really hardworking on all the digital model, all the digital transformation that will be used to have a space 4.0, as well as to design new sensors in the evolution that I just sketched. And just a few words before to hand my talk. We have as well a an economy evolution also in the exploration. Our capability, after 20 years of operation on the International Space Station, we learned a lot how to operate in microgravity. And I think this is the base for what we plan today with the new low Earth orbit systems. Why not? With the evolution of commercial space stations, with the capability to access a low Earth orbit, for instance, with vehicles like a Space Rider. This is extremely important to explore this new dimension of the space economy. And using this base and those technologies to address the evolution to be on the planet, on the moon, back on the moon, not only for to work for a few days, but having the aim to stay on the planet, to work on the planet, to understand what we can build on the planet. This is opening the way also to a kind of lunar economy, where, just an example, we need connectivity, we need communication between and among different actors on the planet and the Earth, and so on. So just to give a snapshot also on this dimension of new space economy, where exploration and the low Earth orbit will be extremely important as well. So at the end, as a final key message, is the fact that the space industry as well is really fast moving to a new paradigm, which is the consequence of what we see from technology evolution, as well as from the change of paradigm in the use of the space data. We have the evolution of our capability to design new class of satellite, small satellite constellations, mega constellation, and of course keeping the pace to design a very state-of-art, high-class sensors. Is a fact that there is a new value proposition clearly address the user-driven or market-driven economy, space economy, from the initial technology push model that for many years was the reference model for the space industry. And it's a fact that today space is really inherent part of the IoT, of the Internet of Things, of the digital knowledge, digital societies. And we know how without space assets, what we do in the economy field, what we do in the sustainability path, what we do in the addressing the SDG cannot be possible. Thank you.
Thank you very much, Massimo, for very exciting programs you have shown. New artificial and new natural satellites will give us a possibility to front new challenges. Okay. Now, it's an honor to introduce also Jean-Jacques Dordain, that is the chair also of the advisory board of the Foundation Amaldi, that is one of the organizer of this meeting. And well, we all know, but we have to remember that Jean-Jacques Dordain has been a director of launches in ESA at the beginning of the millennium, let me say, and then from 3 to 15 of this century has been well-known ESA Director General. So we have a recorded contribution, so please I ask to Federico to show the reel of Jean-Jacques Dordain. Okay, now finally we have a real conference because we encountered a technical problem. So we can go straight forward, and so because I see that Luigi Pasquali is online. Luigi Pasquali has been is coordinator of space activities of Leonardo and the CEO of Telespazio. Okay, his long track record in communication, starting with the well-known in Italy, at least, Selenia industry. So currently is in the board of director of Thales Alenia Space, not only Telespazio, and also of Avio. So please, Luigi Pasquali, you have the floor. You can speak.
Good morning. Thank you, first of all, for having invited me to this new edition of the New Space Economy ExpoForum. Let me start from a clear and important lesson that the enduring health emergency we are going through will leave us. In a globalized and hyper-connected world, most of the challenges and problems cannot be tackled individually by single nations. The impacts of climate change, the fight against natural or man-originated disasters, the protection of strategic and fundamental assets for our daily lives are issues requiring prompt and transnational responses. Europe has become increasingly aware of the contribution that space can provide in this regard. Following the indication of ESA, high-level advisory group of distinguished personalities, recent Matosinhos manifesto has clearly pointed out that the enormous untapped potential of space, despite its significant benefit for society and economics, are increasingly evident. Let me focus on three priorities areas highlighted in the manifesto, three accelerators able to further advance Europe's space ambitions, and at the same time contribute to the solution of global issues. The first is the space for green future, so the challenge of climate change. The second, rapid and resilient crisis response, so the challenge of emergency management, and the protection of space assets, which is the challenge of space domain awareness. Starting from the first, space for green future. The most urgent crisis, as the recent COP26 reminded us, is that of climate change. Time to reach the goals set by the United Nations for 2030 is getting shorter and shorter, and the consequences of climate change are becoming more and more evident. It is not only the environment that is under attack, but society, people's security, work and economy as a whole. The latest report from the Intergovernmental Panel on Climate Change indicates that the 2 degrees Celsius warming is likely to get exceeded by the end of this century, unless immediate and deep reductions in greenhouse gas emissions are initiated immediately. Space data have been invaluable in understanding the problem and will increasingly so in the future. Thanks to data collected from the Italian Cosmoskymed satellites and the Sentinels of Copernicus program managed by GEOS, today we are already able to monitor the melting and movement of polar ice caps, the increase of sea level, water and land consumption, abusive deforestation, and lots of other metrics. Today, however, space technology can go far beyond mere monitoring. The sheer volume of data from satellites enables the construction of predictive models that will radically affect global decision-making and machine learning. The next decisive step is anticipating problems and providing solutions before the damage becomes visible. Emblematic of this race to anticipate the future is the Digital Twin Earth project being worked on by the European Union, a digital replica of the planet constantly fed by Earth observation data combined with in situ measurements and artificial intelligence. The model will simulate the evolution of the atmosphere, the oceans, the ice caps, and the land with a degree of precision that was unthinkable until now. It will also attempt to visualize human behavior, enabling world leaders to predict the impact of weather events and climate change on society and evaluate the effects of the various climate policies. Telespazio, through its subsidiaries Telespazio UK and EGEOS, has already been involved in other pilot projects, like the Digital Twin Earth Precursor. For example, the Climate Impact Explorer prototype is focused on providing advanced draft frequency metrics and water scarcity parameters in climate change scenarios in area of Africa and the United Kingdom. Based on a combination of models of the Earth's surface, Earth observation data and artificial intelligence system, the prototype makes it possible to better characterize, understand and forecast the local impact of global climate change. Over the years, Leonardo Group has developed important skills in the field of Earth observation. Cutting-edge radar developed by Thales Alenia Space for the Cosmos Skymed satellites, hyperspectral technology, electro-optical instrumentation, attitude sensor and solar panel made directly by Leonardo for Prisma, and user ground segment and application platforms with the merging of different types of data through Telespazio and EGEOS. The second accelerator is the rapid and resilient crisis response to manage emergencies. Climate change is strongly linked to many of the crises facing Europe and the world. In July, West Germany experienced catastrophic flooding that caused damage to buildings, infrastructure, the environment, and people belongings. Before this, Germany was witness to extreme flooding in June 2013, which was one of the most severe large-scale flooding seen in the country in the nearly 6 decades. Some other countries were also affected during this time, including Austria, Switzerland, Poland, and Hungary, among others. In Greece, during the summer of 2021, thousands of people fled parts of the country due to the raging uncontrolled wildfires. According to the European Forest Fire Information System, about 128,000 hectares were burned. Like to say 6 times the average area burned annually between 2008 and 2020, and in Italy about 156,000 hectares, almost 4 times the average annual area burned between 2008 and 2020. More severe situations than in previous years are also in Spain and Cyprus. Earth observation has become indispensable in emergency management, such as wildfires. European Union Copernicus rapid mapping coordinated by EGEOS are really effective instruments. The maps produced by the services supporting early stage of the emergency allow to delimit the event, to estimate its progression, to identify its sources and find the nearest reservoirs. Maps also allow to quickly identify the areas exposed to immediate risk and to plan the consequent measures of protection and evacuation. The maps produced by the services supporting the early stages of the emergency allow to delimit the event, estimate its progression, identify its sources, and find the nearest reservoirs. Maps also allow to quickly identify the areas exposed to immediate risk and to plan the consequent measures of protection and evacuation. Experience in emergency response was especially valuable in phase 1 of the COVID-19 pandemic. A couple of examples from Telespazio. A project that we call ECO4CO, awarded by United Nations in 2020, which involves the use of artificial intelligence to integrate satellite data and information from the web in order to isolate new outbreaks of COVID-19 and monitor the areas where people tend to concentrate. In this way, using predictive analysis systems and an autonomous acquisition of satellite data, as well as a tracking and data learning ability, the platform supports systematic surveillance of areas of aggregation, such as parks, public markets, and sports stadiums, supplying data on human activity and on any possible gatherings. The information obtained can help to isolate new outbreaks of the epidemic. ECO4CO also offers a view of the epidemic dynamics and the predictive analysis service for identifying future requirements for stocks of medical equipment. The monitoring of port activities is a second example based on the integration of satellite data with other types of data, is also a contribution to sustainability through the creation of indicators describing the impact of COVID-19 restrictions on the economy. A third pillar that I want to underline for the forum is the protection of space assets, the so-called space domain awareness. To keep taking advantage of all the benefits that the space technologies make available to us, especially when it comes to sustainability, space activities must be sustainable themselves, and near space must be included among the resources to be preserved. About 36,000 objects larger than a tennis ball are orbiting around the Earth, and many smaller than that size. Each of them is a constant threat to active space objects. Space weather events also pose a real threat to strategic assets. In this context, it becomes essential to build the autonomous capacity at the European level to provide the necessary information to the authorities in charge of the protection of critical space assets and the assessment of the risk of large objects return to Earth. The kind of services that we like to underline for the protection of space assets are the space traffic management first, which means the assessment of the probability and the impact of conjunction, breakup, re-entry events, the determination of collision avoidance maneuvers during routine operations, the support to the launch and to the end of life and the orbit phases of satellite assets. The second is space weather. Is the alert services in case of event generated by solar storms of significant intensity, with the aim of preventing and mitigating the impacts on the orbital decay of satellites, on satellite communication, on the operation of satellite positioning systems such as Galileo and GPS, and on the traffic of onboard electronics. The third is the advanced space intelligence, functions to monitor the release of unauthorized and controlled objects into orbit, to determine the mission characteristics of unknown space objects, to provide an alert services for suspicious maneuvers with coverage of all orbits. Such a service requires the management of a huge catalog of trajectories and classification in continuous evolution. The solutions studied by Telespazio are based on innovative models of artificial intelligence, machine learning, and big data mining. Leonardo Group can contribute to sustainability of space. This is a real priority for us, avoiding the creation of new space debris as first, and also by building a new generation of satellites capable of completely burning up on re-entry into the atmosphere, which is in charge of terrestrial space, classifying existing debris using ground and satellite sensors, like a North Star program in which terrestrial space and Telespazio participate, and performing space traffic management activities and collecting and neutralizing existing debris in orbit, which is a priority for all our space sector, in particular for Telespazio, as a routine of control. This is our contribution of your debate and discussion, and I wish that the new Space Economy Forum will be successful and interesting as usual. Thank you.
Good morning. Cannot say that I am happy to be with you, but I am happy to be part of this new edition of the New Space Economy Forum. I would have preferred to be in Rome, but it's still difficult. Roberto asked me to present the report of the expert group set by the ESA Director General last summer. He could have done that himself, since he was one of the experts. And I am sure that the Director General of ESA has already spoken about the report. And even more, I am sure that most of you have already read the report. So there will be no surprise in the next minutes. and not easy to keep your attention since I don't even see you. But I shall try. I shall try by sharing my personal reflections about first, the group and its work. Second, the report and its content. And third, the next steps and their challenges. About the group and its work. The group was made of 9 experts. And the diploma of expert is not standardized. It was just the decision of the Director General. But the mark of this group was on the one hand, its diversity. Diversity of gender, diversity of nationalities, diversity of age, and diversity of experience. And on the other hand, the unicity of its objectives. To be useful for ESA. The result of that diversity and unicity was a multitude of exchanges based on the proposals made by the Director General. Exchanges among the members and exchanges between the members and the executive. I must report that uniformity was not the mark of these exchanges. We have seen a lot of different opinions, but there was a convergence process. And the convergence process was driven by the convergence between, on the one hand, Europe's interest, and on the other hand, the capabilities of ESA. So we could move from diversity to consensus. And the final report is supported by all members. It is certainly a reduction of scope compared to the richness of the exchanges. But this is certainly not a reduction of momentum. As a matter of fact, some exchanges were related to other topics, and in particular the transformation of ESA. But the transformation of ESA must be associated to implementation of concrete programs. And this is the reason why some of the exchanges are not in the report, but they could benefit to the Director General, if he likes or not, his decision. About the report and its scope. The report starts by the problems to be solved in the world, and the role of Europe to alleviate these problems and their consequences. The focus was on societal challenges, climate change, security, education. These challenges have been already translated into the so-called EU agendas. Digital agenda, green agenda, safety agenda. Because it's always better to identify, understand, and respect the problems before designing and tailoring solutions. For much too long, we, the space actors, we have first designed solutions and then look for a problem fitting with the solution. It's not possible anymore. We have to tailor and design the solutions according to the problems and not the other way around. Then the report focuses on ESA solutions, response to the societal challenge, taking benefit of the capabilities of satellites to collect data at both global and local dimensions, which is key for climate change, because the causes are global while the consequences are local. But also the unique capabilities of satellites to replace ground infrastructures, which could be destroyed after natural disasters. Then the report underlines the sense of urgency because this societal challenge cannot wait other years before we are able to provide solutions. And this is the reason why what we have proposed are focused on what we have called accelerators. The number of accelerators have been reduced compared to the original list of the Director General, because we wanted to focus on the most urgent challenges. We have defined 3 accelerators. Number 1, rapid and resilient crisis response. Number 2, space for a green future. And number 3, protection of space assets. These 3 accelerators are going together. They are just 3 dimensions of the same objective, which is understanding, monitoring, and alleviating the consequence of climate change. But we cannot wait either for preparing the long term, because the long term of today is just the short term of tomorrow, and we have to be prepared to avoid the cost of not being prepared. We have unfortunately paid a lot in the last years of having not. So this is the reason why there is 2 inspirators in addition to the 3 accelerators. The name inspirators have been found after the report has been issued, but this is exactly what we meant. And these inspirators are there also to consolidate the leadership of Europe for the coming decades and attract new generations. The first one is prospects of an icy moon sample return mission. And the second, the Europe's capability for human space transportation. So it's 3 accelerators, 2 inspirators, and I would say 1 attractor, because space is an attractor for young generation. So in order to be accelerators, they need a new type of implementation, meaning additional resources, meaning new sources of resources, be it societal budgets, private sources, commercialization, and also an innovative implementation inspired from the building up of startups in successive waves. But the accelerators must also rely upon the solid ground of all other ESA programs and associate industrial capacities. So it's not either or, it's both. This is the topics for the next steps and their challenges. Obviously, the next steps belong to the Director General and the Member States. But accelerators cannot be implemented without the EU, because this is just connecting space and society. For the expert group, unfortunately, the value of our report will be measured only later by its concrete implementation, and even more by their benefits for citizens, meaning that we don't know yet if our report has any value. Again, urgency matters, and we are all anxious to meet the results soon. We have been actors for 3 meetings only. We remain ambassadors. We shall be the spectators of its implementation, and we hope to be the beneficiaries as simple citizens. As a conclusion, we have been happy to contribute. We have been happy to be among friends of ESA. And I have measured that my distance from ESA have not decreased my attachment to ESA. On the contrary, as you know, 2 satellites linked by a tether in orbit produce energy, and I have got a lot of energy from ESA. Beyond our collective pleasure to support ESA, I wish to conclude by focusing on the title of the report, Accelerating the Use of Space in Europe. To accelerate, you need an engine and fuel. The engine is the people, all of them, from all organizations, national, intergovernmental, European, all industry, all enterprise, all investors. The fuel is just the money. People are there, gifted and motivated. Money cannot be to the detriment of ongoing ESA programs. Transferring is not accelerating. So the report is just a small step forward. And as usual, the most important is the next step. Thank you very much.
Okay. Thanks to the directorate, to organization for rescuing this very interesting video from Jean-Jacques Dordain. And now it is time to give the floor to Frederic Nordlund, that is currently head of the European and External Relations Department, Directorate of European Legal and International Matter at ESA. Very long, but very important, because is also one of the tasks is also to assist the Director General in this dangerous field of legal tricks and tracks. So it's a pleasure for
Okay, good morning, everybody. Mr. Chairman, Leopoldo Benacchio, thank you very much for your introduction. It's a distinct honor for me to be part of this keynote session of the New Space Economy Forum. And I would like to personally thank Professor Roberto Battiston for inviting me for this keynote session. I have the privilege of having a job that allows me to look at domestic affairs, European relations, and international affairs, external relations. And so what I would like maybe to do this morning is noviograph, just to spend a few minutes of what I observe out of, in particular, the international community. That could be some interesting entries and inputs for the reflections during the next days of this forum. And what I would share with you would not come as a surprise because it's really a confirmation of the fact that the high-level advisory group that Jean-Jacques Dordain just presented, and to which Professor Battiston was not only a member but a great contributor, was right on target, observing, of course, first what was going on in Europe and then outside, and coming with these proposals of accelerators and inspirators. So first and foremost, Europe is part of a global community, global space community, that is an ever complex one, a very challenging task for anybody interested in external relations to actually follow and analyze all the developments going on in the international space community nowadays, more than ever before. One could start with just a few basic factual information. We have an international space community composed of 85 nations having a form of national space program. So 85 nations conducting their own space activities out of 200 and something 10 or 15 nations around the world. But the footprint of the use of space data and services is, of course, much broader than the 85 nations. It is probably at the moment at the 180 to 190 nations globally. So almost all countries in the world are using space data and services. We do not have yet the numbers for 2021, but the global space economy is meant to be at something like 370 billion euros in total volume, with a share of that total volume of this 370 billion for the public space budgets at almost 80 billion, and everything else being for private and commercial revenue. So that gives already a good sense of the general balance of what's going on around the world for space activities. The pace of launches in 2021 is extraordinarily active, something that was not necessarily affected by the COVID-19 pandemic. Just to give you a few of my personal counts, there are at the moment 50 launches in 2021 for China, 46 launches for the United States, and counting. The year is not yet finished, so they will probably reach in the US the mark of 50 and in China above 50. So just for those two nations, you see the extraordinary number of launches this year. The pandemic has not affected all the space sectors in an even fashion. Some were more affected than others. Some had to delay some programs and activities. So while we've seen a lot of, outside of Europe, a lot of activities in the US and China, or in Russia, for example, we noted that nations like India were more affected, and Israel, in particular, the Indian Space Research Organization, was more affected this year because of the pandemic and had to delay, a number of missions. 2021 and the global space sector is also showing something which is quite extraordinary. It is the number of active satellites launched this year. We are a little bit above 1,500 satellites launched this year, which is an historic high. For the past 10 years, just to give you an idea, the average number of satellites launched per year was about 840. We're now going at the 1,500 satellites per year mark. And this is, of course, showing a trend that has been mentioned by my Director General, Josef Aschbacher, and by other members of this session, and a trend that is even going higher, according to a number of consulting firms who think that for the next 10 years, we should be average at 1,700 satellites launched every year. So 17,000 satellites to be launched over the next decade, which shows, of course, all the opportunities that are seized to benefit out of satellites and space investments, but as well as challenge, of course, in the coming years, in particular in the domain of the well-known space traffic management. In terms of public budgets, it is too soon to fully assess 2021, but definitely we see significant increases in space budgets, public space budgets for defense, for civil activities, in particular in exploration, for example, where we see a large increase in investment. And what is, and I think this is very, very relevant for this forum, what we're seeing as a general trend when we observe a number of countries around the world is definitely both an acceleration of the privatization of a number of functions that were actually managed and led by the public sector, and on the other side, an increasing commercial space activity. The privatization of activity, and I would like to start with this because I think it's something that is not always followed so closely in Europe, but I think it is very important. We're observing, for example, a much broader and important trend in the privatization of space activities in the US in the context of national security and defense, but also for NASA, for example. NASA is enlarging its portfolio of privatized activities, either be it in the future for data relay or for the provision of spacesuits for future exploration activities, and of course for the well-known commercial crew program that has produced already several flights to the International Space Station. But my message is basically what we're observing in the United States is a deeper privatization through which the public entities, defense, national security, or civil space program are procuring services and products, but relying fully on the development of the private sector. The second trend is definitely a much broader and active commercial space activity. The US remains, for the time being, by far the most vibrant private sector in space, with different trends that are being observed at the moment. One is vertical integration of new space companies in the US. And I would not go through the list of these companies, but it's quite visible that we're seeing this vertical integration trend, allowing these companies to come up with an offering which is much broader than what it used to be before. The second trend that we observe in the US is the special purpose acquisition companies' investments, very significant investment in space startups. It is many of the analysts at the moment are diverging on their prediction of what the SPACs, special purpose acquisition companies, will do in the next years. Will this type of investment remain at this high point, or will it decrease? This we will see, but at least for the time being, the consequences of such investments mean that the valuation of the new space companies in the US is at a very, very high point, and that these actions have allowed some of these companies to go to be publicly traded. And I will not mention the name, but there is a representative of one company in this forum that has started public trading just yesterday, and it's quite a significant development. Proliferation of small launchers in the US, China, Japan, and India is also something that is noticeable in 2021. And would just say that as much as we look into what's going on in the US for the private sector, we should also look into what's going on in China for the private sector, because at the moment there are more than 200 Chinese private companies coming up with new developments in terms of small launchers, in terms of satellite constellations, in terms of new services being offered on the international market soon, on the domestic market first. And this comes from the fact that China opened up a domestic trade space for these private companies in 2014. allowing them to have a certain level playing field domestically. And we're seeing this effect now and this growth of numerous Chinese companies. Likewise, we see a marked development towards commercialization in Japan and in India. And those are the two other nations where we're seeing an active pickup of these private activities. And I would also mention one other country, South Korea, because in 2021, South Korea really announced new governmental measures to foster commercialization of space and to grow their domestic companies. And it's quite a remarkable development to see in such a short term. So the sense of urgency was a recurring theme of the high-level advisory group that addressed the accelerators and inspirators. And when you look a little bit closer to what's going on internationally outside of the European borders, you can only come up to that same conclusion. A sense of urgency for Europe, first to have a very accurate reading of what's going on internationally, to draw some of the lessons, but also to assess together all the opportunities for cooperation to expand the European space program effects and impact, but also to assess together with cooperation the competition that is coming our way in the coming months and years. And I think it is more important than ever before. I think I would like to expand on a few remarks that were made by some of the speakers this morning. For example, Mr. Comparini mentioned the birth of the economy in low Earth orbit or the upcoming lunar economy. This is definitely a strategy in the United States. NASA now has a commercial low Earth orbit strategy with key steps to acquire services from companies for low Earth orbit activities, and this would in particular be developed in parallel to the International Space Station, but mostly after the ISS. And you've heard probably of many announcements of companies in the US that have been proposing lately private space stations in low Earth orbit for the future. And I think this is an interesting trend that should have us in Europe really reflect about how we want to address this. And I think the Director General of ESA this morning was very clear in his presentation when he said that one of the inspirators is really to ask now the question, and it is critical to ask now the question to see how Europe will position itself in the future vis-à-vis this type of developments. So the other competition, which I would like to mention, and this one is really not related to a space agency like ESA, but I think it is an important development that has to be taken into account collectively in Europe, is the acceleration of the international competition for space data production. Yes, and this was mentioned by several speakers this morning, space data collection, analysis, storage, and services. So I'm referring here directly to the cloud providers, such as Amazon through Amazon Web Services, or Microsoft through Azure Space Orbital, or the Chinese Huawei or Alibaba. They have definitely targeted space data and storage and services as a main business line for the future, and noting that space data is more than ever before, and certainly 2021, part of the global data economy. So this is, I'm mentioning this just as a personal remark, but I think I note this as something that has to be followed, because this is absolutely critical for Europe. And we've seen the European Commission lately very focused on growing European led activity in this domain, and it is believed that this should be really the right direction to go for. But I just wanted to highlight this other form of international competition. I would just spend a few last minutes about some general reflections about, again, international developments that may be addressed later on by my fellow panelist, Xavier Pasco, I'm sure. But there are other developments, international developments, that have to be integrated in the European reflection. One is definitely a trend, or at least an evolution of military space doctrines around the world. Now it is openly stated by several nations that space is considered as a warfighting domain. And that comes, of course, with the doctrines and developments that have to be taken into account. And this is, I mentioned this just as a sort of a general background information, but one that we have to recognize. A greater alignment between space and cyberspace in a number of nations as well, in terms of protection of assets or in terms of operating modes. And definitely a protection doctrine in orbit, and for some nations like the US, for example, even beyond, meaning including now the cislunar space environment, which is also an evolution of the general doctrinal approach of a number of nations. Within this, we see, of course, the effect, in a sense, of the general political tensions of the moment on a number of space developments. The Director General of ESA mentioned a recent anti-satellite test that is probably one proof of this. The other one could be, in a sense, the fact that the world has now two space stations in orbit, the International Space Station and the Chinese Space Station, which is another form of looking at a sort of, two activity in human spaceflight in orbit being carried out at the moment. But also in the field of exploration, where you see really, on one side, the Artemis program led by NASA, and on the other side, the International Lunar Research Station that is being proposed now by the China National Space Administration and Roscosmos. So, message here is there is a certain fragmentation that is starting to be observed in the world of exploration, and one hope that we would be able to see continued international cooperation in these key domains of human spaceflight and exploration in the future. Just to come back maybe to now European affairs. I've been trying to describe probably too briefly some of the observations of the moment of what's going on internationally. Within Europe, first of all, I will retain my hat of external relations to say that international cooperation is at the center and absolutely key of for the ESA programs and activities. We have extraordinary highlights, and I would like just to mention two that are coming up very shortly. First is the launch of the NASA, ESA, Canadian Space Agency, James Webb Space Telescope on December 22nd. This launch on Ariane 5 from French Guiana. This is really an historic launch, great responsibility, and also, the final phase of the development before the deployment of this extraordinary telescope that will bring a real revolution in astrophysics. And Professor Battiston would know much better than me all the benefits that the James Webb Space Telescope would bring. But if you have any questions about whether Europe, and in particular ESA, can be on the critical path of major space missions? The answer is yes. We're on the critical path of the James Webb Space Telescope. And we are also on the critical path of a mission that is being launched very soon into 2022. It's the Artemis 1 launch of NASA with the new SLS launcher and the Orion capsule and the European Service Module. And this is the first launch that would uncrewed, that would go back to the moon after the Apollo mission. And I would just indicate that there is an ESA logo on that launcher, and there is a European ESA contribution, thanks to the great performance, by the way, of European industry, so that we're able to be there for this launch. So yes, we are on the critical path of major international undertakings, and we will continue to do so. As Jean-Jacques Dordain said, the fuel is definitely, future investments. You've heard of 3 accelerators described by the Director General of ESA. You've heard of 2 inspirators, also described by Mr. Aschbacher. This is exactly the type of future investments that needs to be carried out to propel Europe and ESA in particular, but everybody, all of us collectively in Europe, to be leading in some sectors, to be on the critical path of others, or to be contributing simply to global solutions for the future using our space investments. So with this, thank you very much for inviting me. It's a great honor and a great pleasure to be with you. Thank you very much.
Okay, thank you very much, Mr. Nordlund, for the change of scenario that you gave us. And because I'm sorry, because myself also, I am an astrophysicist, we are all crossing fingers. No more to say. I had a problem with the microphone. Sorry, so I was saying that because of your long experience in Washington as a representative of ESA, you have been appointed with the NASA Exceptional Public Service Medal. Okay, 11 years. So it's a pleasure to acknowledge this, because technical. And this also gives me the means to introduce Professor Chris Rapley, that is a climate science scientist at the University College in London, and has been appointed Professor Rapley with I Googled because I'm really sorry, I didn't know, as a commander of the Order of British Empire, that I see that is a very high kind of medal, and also as a scientist, also Edinburgh Science Medal for having made a significant contribution to MECA, so also to me, okay. So you have the floor, Professor. Thank you.
Good afternoon, everybody, and thank you for the introduction, Professor Battiston, and for the invitation to be here. Could my slides be showed, please? Good, there they are. My background, as you've heard, is as of a climate scientist, but with a long career history of association with space science, and particularly Earth observation, but also as a director of the British Antarctic Survey. So I have visited and understand the polar regions, and as director of the Science Museum, where I was very interested in how one engages the general public and others with the messages of science. So my task this morning is to just add a little more color, to rehearse the story of climate change and see where that leaves us with these very interesting prospects for accelerating the use of space to deal with this tremendous societal problem. So I called my presentation, so how does this move us forward? And we'll come back to that question at the end. So I start with this space image of the planet. It's not the one that is normally shown, the blue marble, which is what everybody recognizes, our beautiful blue planet hanging in the darkness of space. But this is an image taken in the thermal infrared, which I like a lot, because this is the heat that the planet is radiating back into space in an attempt to balance the energy that it intercepts from the sun. And I like this image because the white areas are the colder high altitude clouds, but the dark areas are what would otherwise be called the clear atmosphere. But of course, in this wavelength, it's not clear. You cannot see the surface because the heat coming up from the surface is being interrupted by these very small quantities of greenhouse gases in the atmosphere. We all know this story, the water vapor, the carbon dioxide, the methane, and so on. And that opacity of the atmosphere generates a temperature gradient across the atmosphere and causes the surface of the planet to be much warmer than it would otherwise be if those greenhouse gases weren't present. Something like 30 degrees centigrade, so a comfortable average of 15 degrees rather than the minus 15 it would otherwise be. Of course, we've increased through our industrial efforts over the last 100 years, we've increased the loading in the atmosphere of carbon dioxide. I checked, and the most recent measurements show that the atmospheric content is currently 415 parts per million of CO2, which is up, of course, very significantly from the 280 where it was when we left the last ice age and has been for the last couple of thousand years before industrialization. More to the point, it's up 2 parts per million since last year. So we are still adding to this load in the atmosphere. And so the planet is still unable to reach its equilibrium. And as a result, the surface of the planet has warmed 1.1 to 1.2 degrees since pre-industrial. And of course, that's the average. It varies a great deal over the surface of the planet. It's 3 times that in the Arctic regions, a little bit more in the tropics, and slightly less over the ocean because the ocean has a much larger heat capacity. So as a physicist, that my fundamental view or framing of climate change is that we have upset the energy balance of the planet. And what we need to achieve is to allow the planet to re-equilibrize, to get back to equilibrium where the energy radiated into space balances perfectly the energy being accumulated from the sun. Now, that energy imbalance is quite interesting because it's the equivalent of every individual on the planet, all 8 billion of us, each having 40 1.5 kilowatt kettles pouring hot water continuously into the ocean. And that's not a bad analogy because over 90% of that energy imbalance goes into the ocean. We don't live in the ocean, so we're not directly aware of it. Ocean ecosystems are very aware of it, but we simply see the consequences that are translated through changes in the atmosphere, changes in the ice, and so on, which I'll come on to. Another interesting fact is that the energy imbalance is roughly 20 times the total energy produced by humanity to run the modern world. So accumulating over time, we have upset the planet in a way that is causing a problem, an energy imbalance, which is more than an order of magnitude greater than the energy that we need to run the modern world. So there are a series of consequences. I've put together this picture show on the top left, surface melting on the top of the Greenland ice sheet. Obviously, anywhere where there is snow or ice close to the melting point, then this warming will have an impact. The melting of the Greenland ice sheet over recent summers has sometimes been as much as 97% of the surface. This is 6 times greater loss of ice to the oceans, loss of ice and water to the oceans than in the 1990s. A second frame showing a flame. This is methane ignited from a methane leak from the permafrost in the Arctic area, Siberia, a lake where methane is being released from the warmed tundra. Of course, methane is a very powerful greenhouse gas, 28 times more potent than CO2. The eye of Hurricane Dorian, and then images of the damages that Hurricane Dorian caused, 290 km/h, Category 5 hurricane that hit the Bahamas, where the damage still exists. And then an interesting picture in the middle of a blazing utility pole. Who would have predicted even 5 years ago that the American energy utility, the Californian energy utility, PG&E, should have to sue for Chapter 11 bankruptcy because of the class actions taken against it, because of the damages caused by wildfires due to its faulty equipment. It sued for $13.5 billion to compensate the 80,000 people who lost family homes, businesses, and so on. And then you see the images continue, impacts on coastal railways in the UK, and of course the dreadful floods that hit Europe earlier this year. So we're seeing consequences, and these consequences are penetrating society in a way that has changed public attitudes. Public attitudes have shifted from climate change being on their priorities, but rather lower, to the point now where at least 80% of voters in the UK want something done. They're not necessarily prepared to change their own practices, but this is now very high on the political agenda. And with an 80% level of support from your electorate, this allows political action in ways that were previously more difficult. So, of course, there are tipping points in the system. This is a highly interconnected, nonlinear system. One can push it incrementally. We know that such systems have the capacity to go through a complete reorganization, a multiple change. And so there are many parts of this system which could cascade and cause a major reorganization of the climate. And this is why the Paris goals were to hold temperatures to well below 2 degrees relative to pre-industrial, and to pursue efforts to limit the temperature increase to 1.5 degrees, because the likelihood of going through these irreversible thresholds and causing such a cascade increases substantially for every 1/10 of a degree that one exceeds the 1.5 degree C guardrail. So this is the quantitative background to those decisions that were taken 6 years ago. The danger is that if we lose control, the physics, chemistry, biology will run away, and the planet will do its own thing, and we will then have to simply cope with the consequences. At least for the moment, whilst we have a chance of not exceeding 1.5 degrees, we still have our hands literally on the control knob and can have influence over what the future of the climate system will look like. And just to illustrate the rather alarming prospects if we don't do that, the UK Met Office published this map a few weeks ago, showing areas of the planet that could become uninhabitable due to heat stress if indeed the temperature runs away to a 4-degree world, which cannot be ruled out. And it's interesting that a report published by Chatham House in the UK recently pointed out that the estimates of working days lost due to heat stress, that is warm and humid conditions which force outdoor workers to stop, reached 300 billion working days last year. That's up 50% since 2000. And it compares with the working days estimated to have been lost last year from COVID, which were estimated to be 580 billion working days. So the working days already being lost due to heat stress are roughly half of the days lost last year due to COVID, just to put it into context. And of course, that is growing all the time. So if those areas of the world became uninhabitable, the people who currently live there, many billions of them, would be unlikely to stay in place. And so it would lead almost certainly to high degrees of migration. And we have seen that the relatively modest levels of migration that we have experienced over the last decade into Europe have already been a threat multiplier. Climate change didn't cause these flows of migration and refugees, but it added to them. The droughts in Syria and in North Africa have certainly contributed. And we know that that has had a destabilizing effect on European politics. it was a major factor. The scare of mass migration into the UK was a major element in the Vote Leave and Brexit campaign. And we know now that right-wing parties are seeing migration due to climate change as an issue which they wish to manipulate in order to gain greater power and influence. So climate change is already having consequences which we're having to confront. So we need to figure out what to do about it. And most recent research on fossil fuels shows that if we're to respect the 1.5 degree guideline, we need to leave 90% of coal reserves, known coal reserves, and 60% of known oil and gas reserves in the ground. The International Energy Authority has been saying for several years there is no justification for future exploration, ongoing exploration for new resources of coal, oil, and gas. There is already too much available to us for us to be able to burn if we wish to respect the Paris goals. Now, I draw an analogy here. The abolitionists at the end of the 19th century didn't say we'll reduce slavery by 50% by 1800, and by 1820 we'll offset any residual slavery by good works. They said this is an abomination. It was an energy issue. This is an abomination. We need to change the way we operate. We are going to abolish fossil fuels. It was an absolute goal. And similarly, with women's emancipation, the civil rights movement, and the growing movement for climate justice, there are absolute goals to address. And we see that the young people of the world, the average age of the world is 31. The average age of a decision maker in the world or politician is 61. But the young people of the world are saying, you are leaving us. Your legacy is an uninhabitable, or at least very uncomfortable planet. And we want something absolute done about it. So whereas we hear a lot about net zero, where some magical form of extraction of CO2 from the atmosphere will offset, supposedly in the mid of this century, residual emissions, for me, the starting point needs to be abolish fossil fuels. And then we can have an adult conversation about how we get from where we are to where we need to be. And maybe net zero will be an important player in this. But for my mind, it's not obvious until we can see demonstrably that those technologies exist. Up until then, the message has to be much firmer and clearer. Abolish fossil fuels. Let's figure out how we get from A to B. More generally, we need to transform the way we power, finance, and govern the modern world. So this is a non-trivial issue, and it's clear why it has been so troublesome to address over the last 30 years since the science community first made clear that we have this problem. We also need to do that quickly, as we've heard. So COP26, the Glasgow climate impact, there was an interesting narrative. I followed the social media narrative on this. And on the one hand, given that there have been 27 years of discussions from a time when the CO2 content of the atmosphere in 1995 in Berlin was 360 parts per million, and it has increased incrementally and inexorably for every COP ever since, up to 415 now. So there was a narrative in the social media and media that the best efforts of politicians was merely blah, blah, blah. And of course, the young people of the world were saying, this is not tolerable. We want no more blah, blah, blah. So what was actually achieved? Did we make significant progress? Well, some progress was made. There were important commitments made on deforestation, commitments made on the return yearly to address aspirations rather than every 5 years. There was a mention of coal phase down, not phase out. The transparency rules were achieved. There were many positive things. But at the end of the day, the estimates are that what was achieved were commitments that would reduce the estimated warming of 2.7 degrees centigrade at the end of this century prior to COP26 by about 0.2 of a degree. So we're still talking about 2.4, 2.5 degrees of warming, which is above those critical guardrails that we're seeking to achieve. And a report by the Chatham House report on climate change risk assessment that came out reminded us that, of course, this is a probability distribution. There is a 1% probability, they estimate, of us achieving 1.5 degrees. There's a 5% probability of our reaching 3 degrees. And 5 degrees of warming cannot be ruled out. So it's clear that the levels of ambition and action need to be much greater. And for those of us who have worked hard to get this message out into society, we recognize that the framing must shift from being an issue, which tends to shut people down, to a story of action. I have been working as a natural scientist with social scientists, members of the neuroscience community who understand the mind sciences, and we have developed approaches using the insights from the mind sciences, from the neurosciences, to help people who have knowledge and understanding from the space assets and elsewhere, to work with those who need that knowledge and information to facilitate their agency. We find throughout society, beyond the usual suspects who routinely use Copernicus data, there are many, many institutions, local councils, institutions, industrial bodies, business bodies, who are stuck and who wish to be helped to find their agency, to be able to act. Agency in the sense of being able to act. So what is the role of space? Europe has this extraordinary and magnificent record of leadership in Earth observation. And we have an enormous array of assets and a growing array of assets. So what is the role? To discover, inform, warn, guide, alert, actively engage, monitor, and verify. For some reason, there we are. I'm interested in the actively engaged to facilitate and accelerate agency. And based on the experience that we have had in the UK, intervening in areas of society that have previously not used space-based or other climate information, that a vision would be to set up multiple agile intervention units who are capable of connecting with creators and users, creators and users of knowledge and information with those who in society who currently do so. We know that those barriers are not to do with the availability of data. We have torrents of data, and most of the efforts that in the past that have gone into this interface have been to improve the accessibility of those data. That isn't the blockage. Usually the blockage is people problems, issues within organizations where people don't know what to do. People are blocked by past practice, established orders. And so exploiting the brain insights, the mind sciences insights and experience to help facilitate co-production of agency to act is the way to accelerate the scale and pace of climate action. So I finish with this slide. It is estimated we make 35,000 decisions each day, from the trivial, depending on whether to have a cup of coffee or a cup of tea, through to the important, where we decide which assets to deploy in space, which ones to support, how to connect people in society. And my experience, having run large organizations, is that it's all too easy when making important decisions, influential decisions, to become narrow in one's thinking, to respond to stresses, strains, constraints within the organization. But every time a decision is made in our private lives, but certainly in our professional lives, we should stop and say to ourselves, well, we know where we need to get. We need to abolish fossil fuels. We need to develop a world in which energy is generated in a sustainable way. And so how did that decision move us forward? And if we do that, then I think we can connect the space assets with society in the way that we all wish to. And I'll finish there. Thank you very much.
Okay. Thank you very much, Professor, for your really interesting, very clear, and just a little unsettling presentation. we have to change, okay, not for us, because at least me, I'm old, but for our son and the whole mankind that will arrive after us. This is very, very important. We are at the end of the possibility of our Earth. Thank you very much. And now it is time to introduce Dr. Xavier Pasco of the University of Paris-Sorbonne, that has been director of the Foundation for la Recherche Stratégique in Paris. He has a long record of projects that managed, proposed, and evaluated. And I'm being intrigued in particular from 100 articles, papers, of course, but from the book, the latest book that I translate, I'm sorry, is in French, La Nouvelle Âge Spatiale de la Guerre Froide au New Space. I can translate for the people that does not speak French, because it's very interesting, the title, The New Spatial Age, from the Cold War to now, New Space Economy. Okay, so thank you very much. You are the least, but not certainly the last. And also this is a must be statement in a serious conference. So please give the floor.
Thank you. Thank you very much, Mr. Chairman. First of all, I would like to thank the New Space Economy ExpoForum for inviting me, and most particularly Professor Roberto Battiston for the kind invitation. I'm very happy and honored to be with you today. I'm the last speaker, so I will echo maybe a lot of things that have already been said, and I'm sorry for that. I will try to share my presentation here. It's something that I didn't try. Okay, maybe I will ask for some share the screen here. Okay, can I do this? Okay, that's right. Okay, I'm not sure. I will maybe I will ask for some support from our support. It would be okay. It doesn't seem to work here. Okay, because of, oh yes, I think I can do that. Okay, I can do it. All right, sorry for this. So I wanted to, I hope you see my screen, by the way. Okay, thank you for telling me. I wanted to, okay, reflect on what we've discussed this morning, either directly or more indirectly or more implicitly, about this, what we call this new space issue. And I'd like to give you some sort of a reading grid for our own European-centered reflections about how we could face this new phenomenon and make the best of it, given the fact that in Europe we have a lot of skills and capital to help us add value on this. So it's interesting as a phenomenon, because as we all know, space has always been the archetype of a government-led activity. Nations have always been key space players with the national interest, and you know that the state has been the central actor since the beginnings of space. It was born in the Cold War, and it's really the example of technology driven by politics, and this is something we have to keep in mind. In my view, it hasn't disappeared so much yet, but still it has transformed a bit. Of course, in this particular setting, industry had a particular role, and it's been the space efforts have been structured around two main actors. I would say the space agencies on the one hand, and in the activity, the industry on the other hand. with space agencies often delegating space systems manufacturing to industrial actors. And the space industry was very close to state usually, and used to be very close to governments and state industry, and especially due to the proximity between space technology and military technology. And this is the history of space. And of course, these large companies have produced a very large industrial tissue, I would say, with a number of subcontractors, smaller companies, etc. All this has settled in the last century and has prospered in a sense, and created a very large social and societal actors. The new thing is that we have seen the emergence in the recent years of the so-called new space actors. I quote here SpaceX, Blue Origin, Rocket Lab. These are, you know, pure space pure players in a sense, without prior experience in the defense sector. This is the first difference, I would say, between this kind of industry and the traditional one. And also, they're coming most of them, a number of them is coming from another industrial area, which is the information activity. And of course, this emergence has brought about some new relationships between this industry and governance and state players. So this is very important to keep in mind, and it's just to give you some very crude basic elements for reflection. So what is new space? We all ask these questions, you know, and with, okay, new space versus old space, you know, there's always this notion of it's better today than it used to be yesterday, etc. I think that's the wrong question. What can we say? And it's been said already in the other presentations. New space, it's the encounter of new technologies, technological processes, and industrialization and commercial exploitation methods. These guys are bringing some new elements in the industrial processes, and there are the use of new methods, new technologies, and equipment that have been developed outside of the space sector for some of them. But also, we have to keep in mind that this is a phenomenon that's been rooted in the American context. In the 90s, this was the time when the United States had to bring added value to what they used to develop for only military and strategic reasons. They converted, I would say, this effort into something new, into something that would give them and that would provide the industry an edge in competition and in global technological advancement. So this is something that has been at the root of the new space, because it has prepared the ground for commercializing space activities. And this was started in the 90s. And the second thing, and I think I will focus on this because I think it's very important, new space is also about an organized junction of the space sector and with the information sector. And I think we have to understand what's going on today, and it's been reflected in a number of presentations already, as a strong connection. New space has been characterized by this very solid, very strong, very enduring connection between two different industrial sectors, and I would say two different sectors of activities beyond the industry. And this is, in my view, the main driver of what we see today. This is the main driver of huge, colossal budget investments, etc., etc. And it is also the driver for raising the interest of non-traditional space investors. Okay, so as you can see, new space is a very combined kind of concept. So we had this evolving role of industry in the 90s, and we have, and this is the second, I would say the second step, you know, the space startups of the 2000s that we have seen emerging, especially in the US. I had here on this slide just a few names of, you all know this, of course, and some of them maybe have terminated and some of them were born since. It's interesting to see that as also a development of what's happened in the 90s in the United States. You have this example, we all know this small.
Sorry, Xavier.
Yes.
Xavier. We have problem with your presentation that is not rolling. So the director of the technical director will keep your presentation on the screen.
Okay.
Okay.
So we will do that. So I stop. Okay. Maybe I can.
Okay. Ecco qua. Voila.
Okay. Very good. Sorry for that. So you didn't see any of my slides. Okay. So next slide, please. Yes, I will go very quickly if you can do it. Okay. So that was my point on the national, the history of space. And the traditional link between space activities and governments. The next slide, please. Okay, and so the evolving role of industry between these times of a very close relationship between industry and states, and these new actors, emerging and starting from scratch, I would say, especially in terms of their relationship with states. Next slide, please. Okay, I told you that new space was both a new way of conducting space activities in a sense, but it has some sort of political roots, especially in the United States. And it is also, and this is a very important aspect for me in analyzing what new space is today, it's an organized connection between the space sector and the information sector. We have really the encounter of two matured sector of activities. So I think we have to keep that in mind to understand where the support to new space is coming from nowadays. Next slide, please. Okay, this is this new 1990s industry, allowed to sell imagery, for example, in this particular case. Next slide, please. And we have had this this second step, with the emergence of the space startups, and I was saying that I was quoting here a number of well-known names now of small startups that have become larger and larger. Next slide, please. These are startups, orbiting satellites for data collection and remote sensing, and you see some example. We all know these features very well now. Next slide, please. And the new thing I was talking about, this the encounter between space and information technologies, we have seen the rise of newcomers who transform data into information. And this is really symbolizing the fact that starting from a few years from now, not so long ago, there has been this awareness that space data could really be used as usual data and transformed into information by being exploited with the right tools and by being merged or even with other kind of data, and you could end up with an image, or you can end up with a figure, you can end up with a curve, whatever. Space is really now part of I would say this huge sector of activity, which is the information gathering and information processing and provision. So I think this is very important, and these small firms you have here are all, working with space data. They're not producing data themselves, but they have started and they strive to start this kind of new activity in terms of producing information. Next slide, please. And you have really now, we're faced with what I call a space information ecosystem, with a number of the left-hand side, the slide, a number of entities ready to inject money, and on the right-hand side into these small firms that are either a producer of data or either a producer of information, sometimes both, And this is something that is burgeoning, with a lot of casualties, of course. Not all the small startups are resisting, the harsh economic conditions, but still, this has triggered some interesting movement that is here, I think, to last. Next slide, please. Okay, so this is just for giving you some benchmarks here. and give you some figures. And so it comes from a consulting firm that I'm quoting their figures here. Something like between 2000 and 2020, something like $28 billion have been invested in 400 startups created in the meantime. It's more than the budget of CNES, I mean, per year. And this is huge. It's mainly US. 80% of the investment by volumes are made in the US, and this is mostly, by the way, Californian. But we see also China, the UK also, and some other countries investing more and more in this. But it's true that from the history of this, the short history of this new space, it's mostly been a US story first, and it's accelerating. 2/3 of the investments have been invested in the last 5 years, so it's something on the rise, you know. So that's really something that is a deep move, a deep movement that will have effect. On the space activity itself. Next slide, please. Okay, I told you that it's not the only, of course, not the US are not the only player in this, and we see some, I would say, some international reactions. You have that in China. It's been quoted by Frederic, I think, Nordlund also. You have also, of course, in Europe, a number of small firms with very skilled and competent scientists and engineers working on this. And so it's interesting to see that this movement has spread, in fact, and it really begins to be some sort of a reference for all of us thinking about the future of space, and especially of space applications. So that's interesting to see how in each part of the world, you know, given the specificities of political and social arrangements and all that, this will end up giving a unified kind of movement. Next slide, please. Okay, this is not only what we have seen is that it has not only developed in the field of space applications. I was mentioning the importance of information, and I will go back to this, by the way, afterwards. But it's also been used, and Frederic Nordlund also was referring to it in his talk. It's been used for more unusual places where it could be used, and especially it's been used by NASA to trigger a new momentum, I would say, in the field of space exploration, in the field of manned spaceflight, crewed spaceflight. And this started in the middle of the 2000s, in 2006, and it's been pushed very much by successive administrations as a new way of envisioning long-term space investments. This is something very specific, and that was very new then. Please, can you go to the next slide? Okay, I just mentioned this. You can go to the next one. We have here, in fact, the history, a complete history. Next slide, please. A complete history of, and you can also progress to the next slide. We have, and the next one, yes. And we have a complete history here, you know, and it's lasting until 2024, 2025 now, and so on. More and more money has been devoted by NASA for delegating to private providers some part of the usual NASA activity. And this is indeed very, very new. This is creating a new form of approach of the low Earth orbit. Maybe part of the Earth-Moon activity will also be affected by that. It has to be, for us European, an element of our thinking in terms of who will be the next partners for states when it comes to investing in low Earth orbit, in space stations, etc. We indeed, I confirm this, what's been said already also. We see that there's a shift in terms of public investment in the US from the LEO low Earth orbit and space stations to what I call the Earth-Moon space and the Moon. And then indeed, the manned spaceflight for LEO will be more and more shared, let's say, to use an euphemism, will be more and more shared with the private sector. So at the end, we have to reflect on what it means in terms of symbolic, in terms of political engagement, policy making, and I think this is something we have to keep in mind. Please, could you go to the next slide? We have two small. Yes, you can go and go to the next. Yes, and then we can then take some step backs and reflect on the future of the new space and what do we see in the end with this emergence of new systems, low-cost systems, etc. We see that space systems are more and more conceived and perceived as a commodity, as an infrastructure. The new space players view space as an element of larger digital and information infrastructure, for example, in the field of space applications. And the way they approach the activity, the way they use their own process, the way they use this very short cycle loop in space design, the way they use even the very weak legal framework that is regulating space, it offers them the possibility to consolidate their vision. And this is what we see today. The blooming activity in low Earth orbit for small, agile, low-cost satellites, and it will be reinforced more and more, makes this movement naturally much ahead of any more strategic, longer-term investment, etc., coming from states. So this is something we have to realize, and we have to maybe work on, as seen from European spacefaring nations, but also as seen from nation states, I would say, worldwide. This is something that has to be regulated, certainly, controlled. At least nations must adapt to this, because the basics of this really rely both on progresses in technology. We can do things with small satellites today that we couldn't do 10 years ago, but also with the fact that there is a huge possibility of new financing coming from information technology and then from private money. And this is something that must be taken into account to adapt to this new situation. And we see that we have new applications, by the way, emerging, and especially we see in the domain of data collection, for example, some activities that used to be even not so long ago, really state-centered activities, becoming potentially privatized activities, or at least commercialized activities, such as, for example, signal or data collection, signal collections. We see that some firms want to enlarge the capability to collect data, even electromagnetic data, etc. Of course, the governments will certainly be the first customers for this, but still it has to be reflected on how the global ecosystem has been transformed. Next slide, please. Okay, I just wanted to refer to the presentation of several of our colleagues previously. Yes, the link with the cloud is indeed the perfect example of this junction between space and the information technologies. The interesting thing that you see that for SpaceX, partnering with Microsoft Azure. We see that with Amazon, being the first world cloud player, striving for having its own constellation to create connectivity. In these two, in the first example, SpaceX bought some sort of bought itself the capability to access cloud customers, and Microsoft bought the possibility for it to access some connectivity it didn't have, and they will. The point was to propose, this reinforced capability to sell it to, in this case particularly, to sell it to institutional players such as the DoD in the United States, etc. The cloud has been really put at the center of a number of strategies in the field of space constellations development, and I think it is something that, of course, we have noted in the European Union. Next slide, please. But then, when you look at it from a distance, you realize that you need three components here in order to create the movement and to feed it. You first have to have a very competent and efficient space industry that is capable to develop this kind of new technologies, to access to space in a very good conditions and very cost-effective conditions, able to field very efficient satellites, local satellites, etc. In the US, you have this. In Europe, you have this. In China, you have this. But you also have to have another kind of player, which is a powerful value-adding downstream sector. It's been mentioned in the previous presentations. Yes, the value-added downstream sector is in fact the engine that will allow the space sector to really develop and maintain the level of activity. And in this case, that I mentioned in the previous slide, you have this strong cloud digital sector with its own financial dynamics. But then it's not sufficient enough. It's not sufficient. It's not enough to have only these two players, that could be on the commercial side. You still have a need for a powerful and a strong public sector that will, in fact, invest rather massively, by the way, to, I would say, start the process, to initiate the process, and to allow these private actors to install their activity and maybe in the end transformed it into more and more commercial activity with more and more diverse and numerous customers that they don't have in the start. If you don't have, and this is my remark here, if you look at the different evolutions we have, if you don't have a massive support from the public sector to engage these new players and create this momentum, and especially the cloud seemed to be an interesting hypothesis for explaining why this public sector would invest in this. It's if you don't have this, it looks like it's gonna be a very short-term effort. So this is something we also have, and it's been mentioned already, to keep in mind for us European, aiming at investing in such technologies. We must not forget that we must also justify the needs from a public perspective, from a governmental perspective, on the midterm to the long term, and we have to accompany space by a favorable environment, both commercially and politically, and this is very, very important. So I think this is a very good, interesting example as drawn from this US landscape, I would say, on the space and the cloud. And I would like to enlarge this maybe next slide, please. We mentioned exploration, manned space flight, and it's interesting to see, in my view, that this model, this three-pillar, I would say, model, could also well structure the future of human exploration. At least this is something that I can propose for your own thinking. These new developments in the field of human exploration may be marked by similar infrastructural visions, I would say. We have these three components. We have a space sector that is very skilled and that will gather international strengths, etc. Do we have a value-added activities? Indeed, there has been these histories about, or at least a proposal about exploiting extraterrestrial resources, etc. At least we have a political valorization at this stage. I mean, it's something that is clearly supported, and especially in the US, by the government. Of course, the theme of the industrial exploitation remains in question, but at least it is in the global picture behind this human exploitation issue. So it seems like you have the way to put some added value on this. And we have this third actor, by the way. We have a budget support by a very strong public actor. In this case, for example, if we take the Artemis program as an example, it proves to be fed with a lot of money. It proves to be supported by international engagements. And so you have a new political and technological context that, in fact, justifies, or at least create the framework for feeding this effort, this infrastructural effort. And of course, on the minus side, you have the long-term uncertainties, because you may wonder if there are changes in political administrations, etc. Would the program endure, etc. I'm convinced that it is now developed to such a point that it will endure whatever the political mandates or options. And it's interesting to see that because of the technology advances, etc., we have a similar evolution than in the LEO part, and the space application part. We will inhabit space in a very different manner than we used to do. Before, we will have more maneuverable space vehicles. We have storage components. We have relay components. We have space stations, cislunar stations, etc. It looks like we're starting a new era in inhabiting space. And this is something that will imply logistics. And all these guys from the new space, they're looking at logistics. They're looking at repeatable industrial activity. And I feel like this kind of approach will be the one that will be in the background of all what we will do in the field of space exploration in the next 10 or 20 years between the Earth and the Moon. And of course, the Moon surface is important, but I think the space between the Moon and Earth is also important. So I will stop there, I think. Next slide, please. Of course, I mentioned the possibilities of exploiting extraterrestrial resources. Next, please. But in fact, it's not sure yet. I mean, the business models, of course, remain to be proven. There are certainly a few international laws to amend, and that maybe put this a bit more in the long term. But we feel like these directions are really here to help structure the future of our space programs and create a new balance, in a sense, and a new win-win situation between governmental programs and new space commercialization trends. Thank you for your attention. Thank you.
Okay, thank you very much. To hold the speaker, my feeling is that we had several really interesting and also important speeches and presentations. And we had a really interesting tracking shot, a scenario of what we are living and what we have to do for the climate, for the space, for the industry. Next session will clarify also all the points that have been stressed this morning. Unfortunately, we have to wait till 3 p.m. for the next session, but the label of the session is resilience, so it is okay to wait. So see you with another chairman at 3 o'clock p.m. on the screen. Ciao.
Good afternoon, everyone, and welcome to the resilience session of the New Space Economy Conference. My name is Salvatore Pignataro. I'm the Counselor for Space Affairs at the Permanent Representation of Italy to the European Union here in Brussels, and we primarily Okay, very good. It seems that you can hear me fine. Can you confirm? Okay, good. So I will continue again. I'm Salvatore Pignataro, Consigliere for Space Affairs at the Permanent Representation of Italy to the European Union in Brussels. Here we look primarily after the space legislative dossier of the Union. We contribute to build EU member states shared policy orientation at the EU Council and monitor the implementation of EU space program and of the other EU EUSPA programs relevant to space. Okay, maybe someone can confirm if my audio is fine, or we should fine-tune something. It's fine. Okay. Okay, very good. It's fine. So I will get. Thank you to the organization for inviting me. And it will be a pleasure to chair this session, and I'm honored to have that many distinguished speakers in the panel, which I will introduce shortly and try and give them the floor without any delay. So therefore, let's get to the theme of the session. Resilience. It's a popular word today, and it has become customary in the space sector. Yet sometimes it might sound a bit undefined and its meaning elusive. So I will try quickly to frame it and then let the speakers to provide their view. So, what's the definition of resilience? I mean, the very general sense, resilience is the ability to get back again strong, healthy, and successful after something bad happens. And more specifically, resilience is the ability of a system, being it a society or an economic sector or also a space infrastructure, to successfully deliver its functions in a wide range of scenarios in spite of adverse conditions or hostile actions. Then I believe we have already a couple of useful elements to frame the word resilience for our purposes. It's a quality that can be external to the space domain. In this case, we want to analyze and understand how space can contribute to build and improve it in favor of societies or policies, for instance, or it's a quality internal to the space domain, for instance, as an inbuilt design characteristic of a space infrastructure. And then the second element is that we talk of resilience, and we need to build and reinforce resilience when threats and adverse conditions are part of the game. So saying that it is more clear that the word resilience, when applied to space domain, has multiple dimensions and can be looked at from different angles. I will start with resilience from space. In this case, we see space as an enabler of effective and resilient solutions to societal challenges, as climate changes or natural disasters. And in this case, space infrastructures enables reliable forecasting and rapid response by offering services based on Earth observation, satellite navigation, satellite communication applications, or combinations of them. As well, space infrastructure can provide redundancy to ground infrastructure. This is a case where space contributes to the resilience of our societies, economies, and values. Then we need also that the space infrastructures are resilient themselves. And this is resilience in space. As Europe and globally, economy and societies relies more and more on space infrastructure for day-to-day life. We need to protect our space-based assets from threats in space, notably space weather events, or moreover, the congestion of the orbits due to the increasing number of satellites and the proliferation of debris. We need the space infrastructure to be resilient to those adverse conditions, and I assume we'll hear a lot about this, about space asset protection in another session of the conference. And we can enlarge this concept even more. The autonomous access to outer space and the safe, secure, and sustainable use of it is vital for the security and the prosperity of our society, and therefore we need and we want and need to look at space as a strategic domain to safeguard our interests and security. And these are security and defense elements to the picture, bringing to a strategic dimension of resilience of space infrastructure and services. Finally, this will be my last bullet point, the economic dimensions. Trends ongoing since a couple of decades are changing the economic paradigm of the space sector. New commercial players emerged, and more will emerge. We will hear from some of them today, and they rely more and more on private investment and commercialization of their products. And to underpin all other dimensions of space-related resilience, we need the space sector in its industrial and economic dimension to be resilient itself to global competition and market risks. So those are how we can frame it. The different dimensions and angle of resilience. So having said that, let's get with no further delay to the valuable content of the session. I will introduce the speakers and let them to provide their view on resilience applied to the space domain, and describe how the institutions and the companies they represent can contribute to one or more of the space dimensions of resilience. So I will start with the first speaker. He will be Guillaume de la Brosse. Guillaume will replace Director Cavada that had an impediment this morning and is unable to join, and she conveys his apologies to the organizers and the fellow panelists. And we regret Catherine cannot make it, but we are very much pleased Guillaume is here and will contribute to the session. Thank you for that, Guillaume. Guillaume is the head of unit in charge of space innovation, startups, and economics at the Direction General for Defense, Industry and Space of the European Commission in the Directorate for Innovation. And previously, Guillaume was assistant to the Director General, Timo Pesonen. Guillaume joined the Commission in 2016 as a member of the Commission's think tank and member of the UK's task force where it dealt with security, defense and space. And before joining the Commission, Guillaume worked for the EDA, the European Defense Agency, as assistant to the executive director and as political defense advisor in the French permanent representation to the EU. Guillaume graduated from Sciences Po in Paris and the Freie Universität of Berlin. So yes, Guillaume has a lot to say, and Guillaume, you are very welcome, and please provide us with the Commission views on resilience. The floor is yours.
Thank you very much, Salvatore, and I hope you can hear me well. Okay, perfect. So I'll continue. I'd like to thank you very much for the invitation, and I'd like to apologize indeed for my director, Catherine Cavada. She had a last-minute impeachment, and that's why I had to replace her. But it's a real pleasure to be with you today, indeed, to speak about space and resilience, because we are very much convinced that space has a lot to bring to resilience. Of course, I mean, I would start by saying that that resilience is at the very heart of the priorities of Commissioner Breton in space, and that for good reasons. Space-based services are central to our economy and society, and will be even more so in a digital decade. Over the coming years, we will use more and more space-based services, and therefore space will become even more instrumental. We will need performant, robust, and secure space infrastructures for Earth observation, for communication, and satellite navigation. And besides the functioning of the economy of tomorrow, military operations increasingly depend on space infrastructure. So on this basis, resilience is at the forefront of the programmatic priorities of Commissioner Breton. Just to mention a few of them. One is of course the modernization of Galileo. You know that we want to accelerate Galileo's second generation. We want to have first satellites deployed by the end of 2024. And here the idea is really to be in a position to deliver more robust and more performant services to many end users, including for governmental applications. Let me mention to you as well a second big initiative that has to deal with resilience, which is about secure connectivity. Here the idea, as you well know, is to develop ultra-resilient telecommunication services, including for governmental use. So you see, this is very much an infrastructure we want to put together in the coming years to provide for a resilient services. A third initiative, you very much aware that we are reinforcing our capacities in the field of space traffic management. Indeed, security in space is critical. We have seen recently, you know, the recent Russian anti-satellite missile tests. What we face today is increasing threats of collisions and even of ill-intentioned acts in space, and therefore we need to enhance our capabilities in the field of space traffic management. We need to have the means and capabilities to avoid collisions in space, to protect our infrastructures that are critical in space. Still, among the initiatives that are very much pushed by the Commissioner Breton and that are linked to resilience, we have the Space Launchers Alliance. And why is it important for the resilience of Europe? Because it is about having autonomous access to space. And this is very much a part of our resilience agenda. And the very last priority I'd like to mention, of course, is the close synergies between space and defense. This is very much high. This is high on the agenda. We want to team up closely space and defense. We want to reinforce synergies between those two domains to enhance resilience. Indeed, for any security-related activity, space-enabled services are becoming essential. So there are no current missions in the field of security that cannot do without satellite navigation, satellite communication, and intelligence from Earth observation. So that's why we need to enhance synergies between space and defense, and that's the plan of the year to come. So you see, in enhancing our resilience in space and from space, we will be able to enhance our freedom of action. We will be preserving as well the functioning of the economy of the years to come. Now, how to build resilience through space? And here we see 4 courses of action. First, of course, we need to fully implement the EU space program regulation. Why? Because for the first time, all the EU activities in space are regulated in a consistent manner, including security. And for the very first time, there is a clear division of labor, a clear roles and responsibilities for security aspects for all actors between the Commission, agencies, member states, and the EIS. So first course of action, first line of action, we need to implement the EU space program fully. Second, we need to put in place appropriate governance. Indeed, an enhanced resilience in space and from space can only be achieved through closer cooperation between space and defense. And for this to happen, we need trust and security guarantees. We are not starting from scratch here. Galileo is already a clear demonstration of what we can achieve when it comes to bringing together space and security and space and defense. It is through Galileo, we have the proof, we have the evidence that it is possible to find appropriate ways of governing a civil program that has a secure and encrypted environment and components. Building on Galileo, what we want to do is we want to make sure that the secure connectivity will be the next dual-use infrastructure of the Union, and that by design. How? First, by addressing the needs of the defense community. The defense community should be one of the end users of that new infrastructure. Two, by onshoring security requirements at the very early stage of the program. And third, by ensuring the control over the system, notably on the most critical services. So what we want to do here really is to maximize dual-use synergies for the benefit of both civilian and military, and to foster dual-use infrastructure able to provide for both open and governmental services, as it is the case for Galileo, and as we want to be the case for secure connectivity. A third course of action is technological non-dependency. Of course, resilience, according to us, can only be achieved if we fully master the technologies that are critical for space now and in the future. And this is why we want to very much focus our investments, our efforts in critical technologies such as artificial intelligence, quantum technologies, semiconductors, and other technologies underpinning on-orbit robotics, for instance. And here we have a strong leverage, and this is Horizon Europe. And this is very important that we use that leverage to ensure to achieve a certain level of autonomy, of non-dependence for those technologies. And of course, a very last course of action is close cooperation with all relevant actors, be it the European Space Agency, the European External Action Service, and the European Defence Agency. Why? To make sure that we all together defend the security interests of the EU and the member states. Just, very last point I'd like to make is the articulation between between resilience and new space. What we see is that we have two major trends. One, that trend towards enhanced resilience on one side. So there is a need for more resilience. And on the other side, what we do see is the emergence of new actors, the new space ecosystems. And here, I think we need to get things right. Resilience and new space are not mutually exclusive. Rather, the contrary, they are mutually reinforcing. They are reinforcing each other. Why? Because new space companies can bring up new ideas, new technologies, new processes. They can push the big players outside their comfort zone. And actually, new space companies can deliver new solutions that can enhance our resilience. And just to give you one concrete example, for secure connectivity, we are now designing the architecture of the infrastructure. To do so, we have commissioned a study, and in parallel, we are commissioning a study to two consortia that are formed by new space actors. So as you can see, we very much want to play with new space actors, with new startups, providing new solutions, new services to establish this program about secure connectivity. So this is the evidence that, again, new space should be part of the agenda increased resilience of Europe. And this is why we should stimulate the new space actors in Europe. We do have talents, we do have skills, we do have ideas, and this is enabled by our leadership in science. We have many startups that are brilliant and dazzling, but when they want to grow and expand, they face major difficulties, and we know that they lack private investment and that they turn to non-EU investors to get investment. And this is a big concern for us. What does it mean? It means that basically all the key technologies, the key services, the new processes, they will brain outside Europe. And that's there is an issue that Europe needs to tackle. And that's why the Commission is willing to stimulate the new space ecosystem. As a public entity, we want to use our leverages to maximize, to really stimulate a new space actor in Europe and to reduce the perceived risk. And what we want to do in acting as an anchor customer, in putting in place an investment capacity through Cassini, we want to de-risk, to reduce the perceived risk and to attract the financial community in Europe to invest in those actors. So that's what we want to do. So dear colleagues, ladies and gentlemen, so in addition to the green and digital transition, resilience is a key priority for this Commission. And what I want to highlight is that space has a central role to play in promoting that agenda of resilience forward. 2022 will be an important moment, an important year for building Europe's resilience through space. With, on one side, dual-use initiatives, I mentioned space traffic management and secure connectivity, and on the other side, promoting, fostering synergies between space and defense. Thank you very much, Salvatore.
Thank you, Guillaume, for your great contribution. I mean, we can understand clearly that resilience is the forefront of programmatic priority of the Commission, as you say, and we have from you as the broad contribution to resilience in space, resilience through space, and resilience of the space sector from the Commission, and you do that by implementing the space program, and you mentioned traditional components of the space program. You mentioned Galileo. You mentioned as well research and innovation, focusing on critical technology, and we understand, we know that the space program contribute as well to the promotion of new space, and you said as well that the Commission contribute to resilience by fostering new initiatives, and you mentioned secure connectivity, space traffic management, and alliance for launchers, and we are looking forward to the next steps of the process that is consolidating those initiatives. Can you provide some elements of the Commission plan for those initiatives? What we can expect after?
Yes, of course. Indeed, I mean, we are very much willing to contribute to the agenda resilience through space, and that's why we are putting together some initiatives. You mentioned secure connectivity, space traffic management, and the alliance for launches. What is to be expected? Well, I mean, clearly those initiatives were announced publicly by Commissioner early this year, back in January. We have spent this year to really prepare all those priorities, those new priorities, and we want to set up in those priorities in motion early next year. There will be a space package early next year that will be composed of a legislative proposal on secure connectivity, as you know, we need a legal basis to implement that program. That legal basis will have to be discussed in details with member states and with the European Parliament, and what we want to do, starting during the French presidency and throughout 2022, to really get all the legal parameters correct, and on that basis, then we will establish the infrastructure. So that's for secure connectivity, and of course we will build on the studies, this interaction we are having with industry to define the big parameters of this initiative. Space traffic management. This is the second element of the space package, and here we do have already initial capacities. That we rely on member states' capacities. Of some member states' capacities. We want to enlarge the scope of member states participating in this initiative to enhance capacity building in Europe. But we want also to address the kind of more regulatory aspect and the international norm setting when it comes to space traffic management, because here it's clear that we need to act together with other partners, including the US, to best define the standards, and that's why there will be a quite heavy agenda when it comes to international cooperation for that part as well. When it comes to the Space Alliance, here what we need to do is, again, we need to formalize the launch of this alliance. We do have still some work to do within the Commission to finalize, the declaration and the terms of reference, and we very much hope that this alliance will be announced by Commissioner Breton early next year, so that we can really accelerate the work towards the preparation of the future, preparation of the next generation of EU launches, and that we need to do within the alliance that will bring together member states and industry to work all together on a strategic roadmap for the launches in Europe. So as you see, we have many initiatives on our plate. It will be structured as well early next year through what we call a space summit during the French presidency, mid-February, where the key priorities on space will be discussed by EU ministers, by ESA ministers as well, and to ensure that we have a joint roadmap for the upcoming year.
Thank you. Thank you very much, Guillaume, for providing us the view and contribution of a commission to resilience and space. Let's move on now to the without other delay, to the next speaker, Mariella Graziano. Welcome, Mariella. Mariella is an aerospace engineer from the University of La Sapienza in Rome. She's member of the International Academy of Astronautics and today is with GMV Aerospace, where she is the Executive Director for Space Strategy and Business Development in the area of flight segment and robotic. And Mariella chairs several boards in the area of exploration and planetary defense. She's very active in the STEAM domain, in the valuable effort to inspiring and attracting young people to science, technology, engineering, arts, and mathematics education. So, Mariella, thank you for being here. The floor is yours.
Okay, thank you very much, everyone. Good afternoon. Thanks for the presentation. Thank you very much for the Amaldi Foundation to invite me and invite GMB to this very interesting conference. I will try to see, because it was not my intention to make a presentation, but finally I have a couple of slides following the. Let's see if I succeed in showing them. I don't know if you can see my screen, the presentation. Yes. Can you see my presentation?
I do see it.
Pardon?
Yeah, I can see it.
Okay, so very quickly, I mean, it was not my intention to make a presentation, but following after this morning and also the discussion, the way the discussion is going, I think it's very interesting to put on the table also an unknown and always forget reality, which is the small medium enterprise, like the company where I'm working. Why I'm saying this is not to make publicity to my company. My boss will be more than happy, but it's really, you know, when I attend those conferences, there is always big stress on LSI, on big players and SME new space. But the reality is that in the middle there are certain entities like GMV, but there are many others which are medium. We have a particular kind of problematics. And why I'm showing this slide, because on the right side you can see the trend of growth of GMV, and you can see that it's a company that is growing from the very beginning. It is still a private company, it's a family company. And you can see that it's growing and growing and growing. Also during the pandemic here, we have been growing, and today I can tell you that we are hiring something like 20 to almost 40 people per month, and we have strong problems in hiring people. So and that's today GMV is the company number 6 for number of employee in Europe, just after the big players like Airbus, Thales, Airbus, Safran, Leonardo, HP. Then there is GMV. So why I'm saying this? Because again, it's not a matter of let's say talking about my company, which is also, I mean, it's also my too, but it's because we have to take into account talking in space in general and talking about resilience. So all the different actors and take into account all the differences that let's say concern to all those actors. So now why we are growing so much in our case, but I can tell you it's only an example. There are many entities which we are, let's say, suffering the same growth, because growing is very nice, but it's also sometimes it's complex. Is because we have been very able to, we succeeded in being resilient. I really liked, Salvatore, your definition of resilience. It was very, I had also like as first line in my speech to define resilience, because there are all those words that start to become a mantra, but they are not, they do not have always the same definition. So I really liked, I'm completely in line with your definition. So with the capability of reacting and going back to normality when something happened. And I mean, we are all facing, last 2 years has been a great example of things of let's say resilience, and how things can react or cannot react. So so resilience is very much, we have to say that resilience, in my opinion, starting from your definition, is very much connected with a certain clear concept like flexibility, like robustness, like rapidity. You know, experts are saying that we are in the middle of a new era. So after the Neolithic, after the invention of the writing, after those important, the experts are saying that we are very close to a change of era. So, and in my opinion, we need to be very careful in how we drive this new era, because we shall try to avoid, let's say, the past. We are already within the future. We need to have the future spread, in my opinion, and in an equal manner. And in this way, resilience is very, very important, because you know, the resilience is very circumstantial and can really depend on the system. Certain let's say societies or economy which are not very strong in technology, they have a very different concept of resilience with respect to economy where the technology component is very strong. But it's evident that no matter the model and no matter the trends of the different, let's say, realities, the idea or the society are attempting to increase their prosperity, their solidity, their richness, their economy. So we have to be very, very careful, because at the end, the introduction, I mean, a clear example are all those infrastructure, going back to space, how space is contributing. It's evident that the space system are becoming a clear enable to a wider range of application and services: communication, Earth observation, remote sensing, navigation, PTN, exploration in a different manner, because exploration is more, let's say, used more than for real services as aspiring the population towards a certain, let's say, growth. But the reality is that those infrastructure, the infrastructure that are needed in space are all very critical, and are generating a kind of contradiction, because from one side they are making our economy much more stronger, but from the other side we are more we have more weakness to respect to certain problems of security, of dependencies from those infrastructure. And I was very in line with what you said in the introduction, and what Mr. Labras said in the former speech. I mean, for me, something very important is that we need to, in Europe, shall be very careful in having all those infrastructure available in an equal manner to all Europe. And this is something that, in my opinion, is not really happening today, because economists used to speak about capital accumulation in general terms to define their economy, and now we could start speaking of infrastructure accumulation, because it's evident that in a world like the one where we are living, technology are going to play very big role. Technologies are going to bring more richness to the let's say, countries where they will be located, or where they will be handled, similar to the infrastructure. And in my opinion, we have to be very careful in having all those things spread in an equal manner along all Europe, because it's evident if we enter in a global as we are in a global endeavor, also the problem are global, cannot be local. So as I was telling, the critical, we are entering in a dynamics where those critical infrastructure are going to solve certain problems, but are also going to generate other kind of problems. You were mentioning about the connection between, let's say, there are very new needs where, for instance, GMB is very active, like in case of the space traffic management. In my company, we are very, very active in the area of collision avoidance, both on ground and on board. We are very much involved in the problems, in something that is very critical at the moment for those infrastructure, which is the threat due to debris or to the solar radiation. We cannot afford those critical infrastructure having malfunctioning due to a collision with a debris, or due to degradation to the solar solar weather. So as I was mentioning, we are very, very active in those areas. We are very deeply involved in active debris removal, not only in Europe, but also in international commercial application. We are very deeply involved in the technologies, critical technologies that would allow in the near future the settling of a big infrastructure, a big orbital infrastructure, thanks to the in-orbit assembly. We are very deeply involved in the possibility of extending the life of existing onboard, let's say, flying elements, satellites, allowing refueling, allowing repairing. So all those things are going let's say, to be very, very important are becoming every day more and more, let's say, important to have those infrastructure resilient to, let's say, tangible problems like the space debris. Similar with respect, for instance, the area of launchers. There are, Mr. Labros was talking about launchers. This is something very important. The capability of Europe of being independent, having an independent access and autonomous access to space. It's very, very important. GMB is working very actively in this direction, not only within the big institutional project, but also in, let's say, commercial initiative, mostly related with small launcher, micro launchers. And we are also there facing the difficulties of having those technologies made available and reaching in a rapid manner the market. As you may know, in Europe, there are at the moment lots of, let's say, lots of initiative related to have, let's say, at a commercial level, in a private matter, small micro launchers for contributing to the, let's say, the need of launching more and more satellites. But again, this is a chain, because as more as we launch, as more we need to think how the entire system is going to be resilient to the problem, and we go back to the need of protecting from debris or from, let's say, or extending as much as possible the life of those elements. Similarly, we are very much involved in Galileo. We are the responsible of the Galileo Control Center. The new Galileo has been just launched, and they are, let's say, handled by our by a system developed by GMB with a very talented European number of industries working together. And this, as you may imagine, they are very, very, very important. The security, lots of technology related with cybersecurity, with the protection of those, say, infrastructure from a cyber attack, and also the how to handle all the data. So there are many, many things that are today on the table that shall be taken into account while talking about resilience. Something that is also very important, again, maybe the model that we are used to shall change, also in terms of cost and insurances, financing. Also, I can think, in order to have a very big resilient system, because we are, resilience is very wide. We are talking about resilience on infrastructure, but in reality, all those things are asking for a global resilience on let's say, the full society, not only at a national level, not only a European level, but at worldwide level. especially because there are some, let's say, aspects that really will affect all the population, no matter the flag where somebody. Something also that was mentioned before by you and by the former speaker is the relation between the civil and the defense. As, again, all those critical infrastructure, by definition of being critical, they need they are putting, let's say, a floor and a top and a roof on the society. So we need to trade off on how our society or our infrastructure will be, let's say, complex and will again enlarge our economy, but with but taking very much into account, let's say, the need of having all those things secure. And then it comes the defense, but we have to be very careful, because when defense stuff enter, sometimes for the actual situation, it comes in some national restriction or regulation that, in my opinion, shall not occur in a Europe, or at least in the Europe that I would like to see. I don't know if I have still time, because I lost a little bit the track of my time. Maybe, Salvatore, you can tell me if I have still. Okay. Okay, thank you. So just to conclude, as I was mentioning before, as I was mentioning before, if it is real that we are entering in a new era, and if the future is already here, then again we have to be very careful in driving the future in the proper way. At the end, we are all complaining about what we did in the past and all the disaster that we did on Earth. But we have to be very careful on the disaster that we might generate in the future, because the complexity of what we are generating at the moment is such that it can be even worse. So for the moment, I mean, I prefer now to stop, and thank you very much for your time and for inviting me again.
Thank you, Mariella, for your comprehensive speech, for pointing out how space infrastructures are critical today for day-to-day life, and how a balanced distribution of benefits from space and opportunities to access space will contribute to resilience. And as well, you pointed out that the ongoing changes, being that of economic or strategic nature, have to be accompanied and monitored to be sure they contribute indeed to reinforce resilience. And finally, thank you as well for presenting how a consolidated space company as a GMV contributed to the resilience of Europe. So thank you again, Mariella, and I'll move to the next speaker of the session. I have the pleasure to introduce Mr. Franco Malerba. I don't know if I need to introduce him. Franco is the first Italian astronaut on board of the Space Shuttle Atlantis flight STS-46. He was the mission specialist of the first Tethered satellite mission. I'm sure everyone remember that. Franco is graduated in electronics engineering and physics, and has got an extensive international professional experience working with leading high-tech industries and research organizations. If that's not enough, Franco was a member of the European Parliament and former scientific attaché in the Italian mission to OECD, ESA, and the IEA. And nice to learn that I am nearly a colleague of you. I regret I cannot say as well, I was an astronaut, but at least we can say that we were both attaché. And Franco is also a freelance editorialist and very much involved in major outreaching initiatives. I believe that Franco is here today as well as the co-founder of Space V, that is a new space company active on greenhouse and cultivation technologies in space. That sounds familiar and very much inspiring to me. I was myself involved in the development of biotechnologies for space manned modules before moving to Brussels. And I believe we can see human exploration and living in space as the last frontier of humankind resilience. So, Franco, a warm welcome. Thank you for being here, and please provide us your views.
Thank you, Salvatore. You can hear me? Yes. Okay. Indeed, thank you for your presentation. Indeed, I flew in space, but you cannot be an astronaut for the whole life. Say, although we keep on representing the beauty, the how should I say, the fascination of flying in space the whole life long. When people ask me to talk about my experience in space 30 years ago, I say, well, definitely we are like priests. We are astronauts for the whole life until the time that indeed we go in sky forever. Anyway, so in the last period of my professional activity on Earth, I have engaged myself with a couple of startups. As a matter of fact, for the past 7 years, I was a coach in the roster of the European Commission to help startups who had won a grant by the Horizon 2020 for their new endeavors, say, and after coaching them, eventually I ended up being part of a couple of startups myself. So we'll see if this move was successful. Today I will talk about Space V. V stands for vegetables. It's in fact the topic that I would like to talk to you about. I hope you see my presentation. Yes, I don't know if I can make it any better, but so this is how it works so far. Let me see here. Why it doesn't? Okay. This is sort of the contents of my presentation. The mission of Space V is to study and develop optimal space greenhouses to accelerate the cultivation of plants in orbital stations and in future lunar and Martian settlements. We heard in a presentation this morning that the lunar economy is a fact in the United States, and as a matter of fact, we are sort of following steps. We heard also about the service module that matches to Orion and will be part of the Artemis program. So we are also looking at Moon and later on Mars exploration. But survival for long periods of time away from Earth requires autonomy. Now we're talking about resilience. This is the utmost level of resilience, isn't it? To resist to the difficulties of space travel and be autonomous from Earth. And by the way, this area of space research is one where mechatronics, biology, food science, robotics work together. So it's a very multidisciplinary field, which is fascinating by its own. And so SpaceV will give hopefully a small contribution in a particular aspect of this new world opening to us, and it's with the adaptive vertical farm. Now, very quickly, because this is a theme that all the attendees to this forum know very well. The ISS, the International Space Station, is where we have learned to live and work in space. We have got, say, acquainted with the micro-G environment, but in a low Earth orbit situation, only 400 kilometers away from Earth, so we can reach the International Space Station in a matter of hours, and so we can provide supplies from Earth. As a matter of fact, this was a very important step forward in terms of manned space flight, because now we have long-term missions, 6 months in space. We have also learned that living in space is not exactly, how should I say, a way to rejuvenate. In fact, the human body is stressed by the weightlessness. We lose bones mass, we lose muscular mass, the immunity level gets affected. So there are a lot of things that need to be improved for the astronauts' well-being in space, and more so for the long-distance flight. In fact, for a space station in a close vicinity of Earth, we need already to provide inside the space station of energy, communications, of course, oxygen production, water recycle. We've been very, very smart by now in recycling all the liquids in space in a space station, and waste management. But we have not done much in terms of food. Indeed, the ISS is continuously supplied from Earth by cargo vessels, being them Progress from Russia or Dragon from the United States. There has been the ATV from Europe some time ago. So astronauts do not produce, say, food on board. They get it from Earth. As a matter of fact, some experiences have been made in the space station about growing plants, and we are comforted by the fact that indeed plants may grow in zero G. I should say in weightlessness. It's more correct than saying zero gravity. And leaves tend to look for light, and roots look for humidity, for water. So they find their ways around in zero G as well. Now I sort of change page and
Franco, if you can hear me, just to say that for some reason your charts were frozen, and now they have uploaded the chart from the studio, and they will move them. Just tell them how they need to step to the next part.
Pity. So, have you followed us until here, until the ISS being supplied by ISS by say slide 5? Where the system is frozen?
No, I guess that they need to move one chart further, and they will be at the chart you were talking about.
Is this? Can you see this with the Crew Dragon space tourists and commercial space travel is getting real? Number 7.
Yeah, I think we are in that chart. Just when you need to stop to share your presentation, and the chart will come from the studio.
Okay. Stop. Are we there? it's very complicated, this system. I have stopped sharing screen. How about you?
I guess you can get ahead, and we see the dragon approaching the ISS.
Right. Okay. So let's move to the next one. I said that vegetables know their way around in space. The leaves tend to the light, and the roots move to humidity, so they find a way in the substrate. So it's possible to cultivate in space in zero G. Let's have the next one. I was saying now, why are we interested in what is the perspective? The perspective is that with the new commercial space activities, I call them space tourism because this is how people perceive it, but in fact it's more the commercial exploitation of space stations that we are talking about. Commercial astronauts may require a better comfort in space. There is a company whom many of you may know, Axiom Space, which is, by the way, founded by a number of former VIPs in NASA, including Charlie Bolden, former administrator, and a colleague of mine, Mike Lopez Alegría, an American astronaut, who have set together the funds to realize to make up a module attached to the International Space Station. By the way, the module has been contracted to Thales Alenia Space, and they will run commercial activities attached to the International Space Station, but eventually with independent independent stations, commercial stations. So in this environment, it's probably welcome a better supply of fresh food, in particular if for rich space tourists who may wish to find 5 stars comfort also in space while they experiment looking at planet Earth and enjoy that view. Next slide then, please. Of course, there is the Artemis program. The Artemis program means moving to the moon. There will be the gateway, which will be also inhabited, not for very long periods of time, but certainly very critical to the whole approach to the moon. In the gateway, we are, and also later on in the settlements on the moon, we will be in low G or in micro G, so again in different weight situations, but we will also be confronted with the radiation environment because we are no longer protected by the atmosphere and by the magnetic field. Earth is only 5 days away. I would say only in commas between because in fact 5 days is a long travel and very expensive one. So the motivation to have autonomous food will be very much at stake. Next slide. The next slide, of course, talks about the destination Mars. Here we are almost at the edge of science fiction. In fact, I put in my slide a shot from the movie The Martian, where Matt Damon grows potatoes in his improvised greenhouse. But indeed, in the 30s, this is the time frame we anticipated, there will be first a circumnavigation of Mars, so a very long mission during which we will experiment being away from Earth at such extraordinary distance, the radiation environment, the micro-G environment, all sort of challenges, one by one. By the way, they're trying not to take them all in one go, in the sense that we will not land on Mars right away, but certainly the need for autonomy will be greatest. The next slide shows what we need to do. We need to rebuild a closed ecosystem, somewhat similar to what we have for free on Earth, with production of food, namely vegetables, some kind of transformation. Astronauts will take advantage of it. There will be some residues which need to be treated, and of course, between the plants and the astronauts, there will be an exchange of oxygen and CO2, very much like on Earth. In fact, the plants keep on absorbing CO2 and producing oxygen. They also emit water. They also evaporate, and this water must be recycled as well. So indeed, the challenge will be to realize a closed ecosystem where, by the way, also waste must be recycled, and this is a whole world of activities and research which has a lot of admiration on my side, because I'm ignorant in that aspect. We are concentrated on the production of biomass, and indeed this is what Space V is aiming for. The next slide. Just a short statement on this circular agriculture for space settlements. In a word, astronauts on Mars will be countrymen, says Stefania De Pascale, the principal investigator and of the Rebus program. The Rebus program is the ASI program where all this world is being studied in all its facets, and it's a group of researchers from university, academy, CNR, Enea, and from private industry, including, of course, Thales Alenia Space. So astronauts on Moon and Mars, in Moon and Mars colonies, will need basic nutrients like on Earth. After all, cereals, wheat, rice, potatoes, legumes, and salads and tomatoes. In fact, there are these microgreens, plants that grow very quickly, reach maturity very quickly, and can that can provide antioxidants, can provide very useful. I get a message here that I should move. I don't know what what to do. Anyway, so I go to the next slide quickly. Space V has purchased a patent from Germina. Germina is a company working in the greenhouse world on Earth. They do it for industry and to increase production, save energy, and reduce the environmental impact. In fact, the original goal, as I heard, was to produce basil leaves in a very effective way, so that they cost the same in summer and in winter when heating the greenhouse is much more expensive. And but Space V is concentrated on the vertical adaptive greenhouse in order to save energy and volume. So what is this adaptive greenhouse? Next slide, please. First of all, the adaptive concept. Plants do not need the same volume, the same, environment during their growth. So the adaptive greenhouse adapts to the growth of the plant rather than fixing the distance between shelves and imposing, therefore, the choose of plants just because of its architecture. Next slide. So during their development, plants go through different growth phases where they require a little space, and our greenhouse progressively adapts the volume available to each cultivation shelf so that it's just what is enough and not more. So there is a mechatronic system. We could call it a little pompously an artificial intelligence system, which learns how to best manage these shelves, adapting their position to the level of growth of each production cycle. And from studies that have been carried out by our colleagues in the University of Genoa, it has been shown that an increase of at least 80% in production yield can be achieved. And by the way, each shelf can be conditioned in a different way, appropriate to the particular crop that you want to cultivate. So next slide. The next slide is quite important. I hope I will manage to make this. There is a video here which I cannot from this distance activate, and it's a very pity if I cannot, because this would show the miracle. There is no way that you can activate the video inside this slide. No. Well, okay, never mind. It's too bad. Well, these technologies must be improved one day or another. I don't know. Remote communications are not as good as we would like them to be. Next slide, then. Well, this is flat, so it doesn't need any particular manipulation, and you can see straight away that the traditional vertical farm has many time inoccupied volume. You see on the ordinates, it's the occupied volume, and on the right side, the occupied volume is 100% all the time. So you can achieve a much better exploitation of this system. Next, let's have the next slide right away. So this is the prototype which we developed and we showed during the Busalla Space Festival. Yes, Busalla is my hometown, and every year we organize a festival since 2017, say popular science event where we talk about space. We have a thread. 2 years ago it was life in the cosmos, then it was water in the solar system, and this year it will be food in space. So we are working at improving the TRL, the technology readiness level. We are studying carefully the performance with a variety of vegetables to be able to give standard measures for this device. And we work with a prime space company. I'm sure you can imagine who this prime space company is, considering that we have the luck to have in Italy the company that has built most of the space modules that are in space nowadays. Of course, next slide, this application may eventually turn back, say, in terms of technology transfer. We took a patent from design from Earth and brought it to space, but eventually we may come back to Earth once we have solidified, say, this project, that we've given it all the strength it needs for difficult situations on Earth, like oil rigs, oil platforms, submarines. We are indeed talking to people who may wish to improve the well-being of the welfare of sailors in submarines, and of course in remote stations in difficult areas. It's Concorde is just an example in the Arctic, but there are scenarios in the desert areas in the Middle East and thereabout. So it's a far-reaching, say, endeavor. We hope that we will succeed. And this is about it. And I thank you for your attention. Thank you so much.
Thank you, Franco, for your presentation. It was great. You presented us the mission of Space V and its technologies and its commitment to study and develop space greenhouses. I mean, this area of space research is very inspirational indeed, and is growing. I'm happy of that, and is a source of continuous innovation. And I want to highlight couple of points from your presentation, and that's related to resilience. Again, exploration is the last frontier of humankind resilience, but those technologies will help also to improve resilience on Earth, and that's very much related as well with climate changes. So they can help in hostile environments and also to save resources on Earth. The other point I want to highlight that from your presentation, it was clear the large competence and know-how that we have at a national level on those technologies. So the very best for your endeavor, and I guess it's time to move to the next speaker. Guess this is a recorded intervention from Michal Brichta. Michal is the head of the Slovak Space Office. He's a co-founder of this newly established Slovak Space Office and the head of its industry branch, working under the Slovak Investment and Trade Development Agency. His team works to support the further development of the Slovak space sector and its internationalization, with a focus on the utilization of the country's strong industrial and R&D potential, and as well with a look to 21st century space trends. He's also the space, the national contact for the space agencies, commission, and other businesses and research entities. So I guess we are ready to listen to Mr. Brichta.
Good afternoon, dear ladies and gentlemen. My name is Michal Brichta, and I'm the head of Slovak Space Office Industry Branch, which is a part of the Slovak Space Office responsible for the sector development and building international collaboration. I'm really happy and excited to be here with you today, even though just like this online, and I would like to thank the organizers for their kind invitation. The word resilience, which is a key element of this session, is very well known and interconnected in the context of space sector, and that is mainly because space is a great enabler increasing the resilience of our economy, environment, and society. in such areas as space for a green future or a rapid and resilient crisis response using space technologies. However, today in my intervention, I would like to focus on something which is one step before that. One step before we can talk about how to use space technology for a resilient solutions here on Earth. And that something is the topic of building a resilient space ecosystem and space sector in an emerging spacefaring country such as Slovakia. Now, Slovakia is not new to space. We have a rich and long tradition when it comes to space R&D dating back to 1970s, but still quite young and relatively small space industry environment. We are a EU member state and ESA, European collaborating state with a plan and aim to become an associate member next year. And we see a lot of dynamic growth in our ecosystem and interest of various stakeholders, which gives us a big advantage when it comes to also building the ecosystem and choosing the way how to do it. Our approach actually consists of three main strategic objectives. The first of them being utilizing the full potential of the sector. Being a country with a relatively small space ecosystem, we quickly understood that we have to do maximum to utilize the capacities and capabilities which are already there. So what we did as a first step was assessing the full potential that can be used for the further development of our space sector. Of course, the first area of this kind of potential is the companies which are already active, but it's not what it's only there. There is also the potential for the technology transfer using the R&D institutions and universities. And last but not least, also the potential of the companies not yet active in space, but having a significant and interesting technological capabilities that can be used there. Speaking about the first category, there are currently a little bit more than 40 companies here in Slovakia. Approximately half of them is active in the upstream area, approximately half in the downstream area, with the strongest segment being the Earth observation application and the spacecraft components R&D and manufacturing. There are also areas which are catching up or emerging, such as the use of positioning and navigation technologies here on Earth, or such areas as ground systems or production solutions. Speaking about the second category of potential, the technology transfer or business academia collaboration, here, as I mentioned, our researchers have had quite a rich experience when it comes to space sector, dating for already decades, and also currently being used in involvement in various international space missions such as JUICE, Pepi Colombo, or Rosetta. Also, every technical university in Slovakia basically has at least some kind of involvement in space-related activities, which is a very good sign. And two of them also already have their dedicated space engineering study programs, which is a good sign also for the future of industry growth. Speaking about the second part and the third category, the diversification or spinning in, so using non-space companies' technological capabilities for space sector. We've worked in this area basically from the beginning of our involvement in space sector development, and we quickly understood that the industrial base here in Slovakia, composed of automotive industry, mechanical engineering, electrical engineering, and ICT, the very, very strong pillars of the economy, it actually creates a very good base for this kind of spinning in towards space sector, and it offers a big variety of high technology companies capable of using their niche technological solutions and really cutting edge technologies also in such sector as space. The second key strategic objective for us is building space sector, which is not only focused and relying on public funding, but also space sector with a commercial drive, sector where there will be also companies capable of attracting private investments, which is being more and more interesting the recent years with growing range of new space segments and new space related markets. So naturally, we are trying to help our companies and startups to penetrate these new markets and areas, mostly around the satellite data, the navigation positioning data, or the Earth observation data. And also we have launched several systematic initiatives that are aimed at building the startup base operating in areas which can also be of interest for commercial investors and customers. We've started to be engaged in hackathons, for example, the European-wide Cassini hackathon that we've been part of this November, and which was a truly wonderful event and helped us to get involved 6 amazing teams coming up with really inspiring and interesting solutions using the satellite data for preserving and helping the Arctic region. And also this initiative was followed by our own project, the Slovak Space Incubator, actually the very first Slovak space-related incubator, which we have launched together with our partners only recently, literally a couple of days ago, in 3 cities across the country, in Bratislava, Žilina, and Košice. It's mostly aimed at creating synergies between the new ventures, new startups, and experienced companies and the research institutions, and helping these new entrants to get ready to prepare their first proposals, first projects, and test their idea against the reality of the sector. And the third area of our strategic approach towards developing a resilient space ecosystem is that we are trying to bring something new to the table rather than just catching up. This means that we're not only trying to develop activities and company activities in areas which are traditionally well populated by companies in the let's say older spacefaring countries and space players, but we are also trying to identify some newly emerging niches that are being created in new markets and new segments of space, where basically everybody is new, and thus it brings new possibilities also for the new players such as our startups or SMEs. This part works quite well, especially thanks to the diversification activity, because you are bringing competitive solutions for spinning in from companies which are well based on Earth and have some highly competitive solutions in other technologically intensive sectors, and we are helping them to get involved directly to this new sector of space technology. Over the past 2.5 years, we actually managed to get 12 new companies like this to the Slovak space sector, which significantly increased the base, and it helped us particularly to identify these kind of new interesting niches. We were also proactively searching for new areas in this newly emerging segments and markets. And that is also one of the reasons that our annual Space Industry Conference, Emerging Space, is, along with the topic of emerging spacefaring nations, also focused on the topic of emerging space domains. Now, I know that I have said that our approach to resilient space ecosystem building is based on 3 key elements, but there is actually an extra one, and that is the collaboration and the international collaboration in particular. We clearly learned that it's the main key to success. The wider your network is, the better the synergies that you can create. And that is why we are also strongly focused on creation of local and international collaborations and partnerships, for example, for ESA-related activities or European Union's Horizon 2020 and now Horizon Europe projects. Over the course of 2.5 years, we actually helped to establish 22 such partnerships, and we in total created more than 130 opportunities to establish such international partnerships. So 130 plus something possibilities of creation and exact project collaboration. And for that, we have mapped and we are all the time extending our international partner network abroad. But of course, still, if you are not part of it, we are always happy to get in touch with new research institutions, companies, or institutional actors to get to know the collaboration possibilities. So feel free to reach out to us. If you would like to do that, here are my contact details. Please do not hesitate to get in touch. Last thing to sum up my intervention, what I would like to say is that I firmly believe that smaller and newer industry players are vital to resilience of the European space sector, and through that also to the space-enabled resilience of Europe. Thank you very much for your attention, and I wish you a wonderful rest of the conference.
All right, very good. We had Michal Bripta about the Slovak approach to building a resilient national space sector for the 21st century, relying on 3 main elements: the national industrial research and academic base, both in the space and non-space sector. Second element was the commercial drive, and eventually innovation, including innovation on a business model. And Mr. Bripta valued as well collaboration at the European level as a key factor for success. I would say that this sounds as a solid and knowledgeable approach to build a resilient national space ecosystem, and which eventually contribute to the resilience of the whole European space sector. And now let's move to another institutional view. Mr. Paul Elias is with us. Welcome, Paul. Paul is the head of the space policy at the Estonian Ministry of Economic Affairs and Communication. Paul has created the Estonian Space Policy Program with Horizon 2027, and today is working on the Estonian national space legislation and on a decentralized e-government solution for space traffic management. And we already heard about the importance of space traffic management for overall resilience. Paul is part of the Estonian delegation to the governing boards of the European Space Agency and of the European Union Space Program. And he has been engaged in various roles in the space sector for the past 13 years, including the successful launch of a satellite EST-CUBE-1, and Paul continued as an entrepreneur in the space sector until in 2016 he joined the ministry. So I guess today Paul will talk to us about the Estonian activities in the field of space cybersecurity, including space traffic management and space cybersecurity exercises. So, Paul, thank you for being here. The floor is yours.
Yes, good afternoon. I hope you can see my slides or not. Yes, now you can most likely see them. So today I'm going to tell you about Estonia and our views on space resilience. So I'm going to tell you more about space cybersecurity, about the e-governance perspective, and also a little bit about our AI activities or resilience, not only how to protect the space assets, but also what we are doing here on ground. If you think about Estonia, then Estonia is compared to Italy, for example, not really known for our space activities. So we are in the space domain, we are a relatively young country. And about 3 years ago, we started working on our space policy to have a long-term vision and to find a clear position for Estonia in the space sector. And Estonia is more known for our e-governance and Estonia's e-country. So 99% of our services or government services are online. So it's everything is quite fast and efficient, and we are well known also for our knowledge in cybersecurity. So it was very clear that if we are building our national space policy, then the main focus should be also on cybersecurity and how can we spin in this knowledge we have gathered already building up e-Estonia in the space domain. And also, if you are thinking about cyber attacks, so it's these are activities or threats that we are facing also in future in the space domain. If slides, yes, maybe some key facts about Estonian space policy. So it was signed by the minister more than a year ago. In case of Estonia, the European Space Agency is for us the procurement agency. So most of our budget is managed through ESA. And as you can see, then the main goal of our space policy is to accelerate the growth of the industry and also find more use of space data and space-based applications in our government. We'll also bring some examples in the next slides. We are also, and the main goal is, of course, how can we spin in our knowledge that we have gathered in cybersecurity to the space domain. And including that, we have also started to work on our national space law, where I will also bring the connection. And of course, it sounds a lot that we are software-based. It's actually not true. If we see our previous activities in the space sector, then actually most of the investments is still in hardware-related activities. And it's also something that we are going to keep and to build payloads and also satellites for various missions and technology demonstrations. So there's also clear activities for hardware development. So we are not only software-based in the space domain. So Estonian industry policy can be divided in 3 areas. First of all, cybersecurity, which is our priority area. Here we are talking about, for example, cybersecurity exercises. In Estonia, Estonian companies and institutions are well known for building cybersecurity exercises where we have built up a fake country which we have to protect, or let's say a power plant. And our vision is to have, instead of this power plant, for example, a satellite or a constellation, and play through different scenarios how to protect these assets in space or the service. And we have started already developing something here in this area. Also e-governance for space. So it's connected now for space traffic management. I will get more into detail after these slides. And under artificial intelligence, we understand different remote sensing applications for smart governance, autonomous robots for Mars and Moon, for example. And under innovation, it's more than optical devices and material science, which I'm not going to tell about during this presentation. So what is, first of all, what is eEstonia? So as every country, also Estonia consists from different databases and services. And eEstonia means that all the databases and services are connected to each other. So it means that most of the services are already pre-filled, and we don't have to fill in all the information again and again, and everything, you can access your information online very easily. So it makes everything fast, and we will save a lot of time. The same, some of the services are also connected, for example, with Finland and other countries. And eEstonia consists from 3 pillars. First of all, how we identify the user. There are different ID cards and mobile identification methods also used in various other countries here in Europe. Then availability, so X-roads is the most busiest road, which connects all the different databases to exchange information. And also, if now we have the data in some of the databases, so how to protect it, so know that the government or users are not changing information there. So therefore we are using blockchain. So there are different 3 different pillars which build eEstonia, and now basically all the 3 pillars can be used for space traffic management is one of the examples. But if you are talking about e-services in general, then remote sensing is, I think, one of the best examples. In Estonia, we have launched a national initiative. It's called KRAT AI, and KRAT is an AI application for smart governance. And these services are also then based on satellite imagery, mainly on Copernicus data, and we have various e-services developed through these initiatives. These applications are for private and also for public sector, which can help then monitor everything which is going on here inside or outside around Estonia. And these services make governance in Estonia more efficient. And what we are also focusing right now is how can, for example, companies update or improve their processes, for example, for sales. How can they accelerate the sales process to find new customers? So, and as you can understand, then Estonia we depend a lot on our e-governance and also on space data, which is also very clear for our politicians, and therefore we understand that we also need to protect our space assets, and therefore, as I mentioned, space cybersecurity is one of our key areas. So how can we guarantee this continuous service? Next slide. Yes, space cybersecurity activities. So we have 3 activities going on in this area. First of all, Estonian space cybersecurity missions. Then we have started an annual space cyber and security conference in Tallinn, which started last month here in Tallinn. and also the work on our national space legislation, which is connected then to space traffic management. So let's go more into detail. So what are Estonian space cybersecurity missions? So the main idea is that our companies, as I mentioned, have the knowledge already in various areas of cybersecurity, how to protect the service or infrastructure, is it a power plant or government? And with this initiative, we are now doing technology demonstration and validation missions so that our companies can bring this knowledge to space. So we have started with the software simulation, and now we are moving forward so that we are sending payloads to space so that we can validate these softwares, for example, data protection, or also in space. We have also initiated cybersecurity exercises together with also with NATO. So, for example, how to protect the ground segment if, for example, a ground station is being hacked. And right now, our industry is developing different new scenarios how to prepare for a worst case scenario. So it's an area that we are continuously improving together with the industry and the government together. And also one of the areas that we are right now focusing on is satellite security testing. So if a space mission is being designed, so we can already start also developing, being sure that the software is safe and no one can really interfere with the service or attack the spacecraft itself. As I mentioned, then we have started Cyber and Space Security Conference. So the first one was already this year. It was a very interesting event with various speakers from all over the world. And we were talking about space traffic management, SST data exchange, Earth observation data integrity, and also space as a war-fighting domain. So to really have the understanding in which direction space cybersecurity is going, and where are the opportunities for the industry, and also how the governments can act. So what should I, as a creator of policy, what should I do? So how can the government be more involved in this area? And the next conference will take place in 2022. So be aware of it. As I mentioned, then in Estonia we are also working on the national space law, and the main idea here is also to build an e-service. So how can we actually innovate with how the satellite registration process is done globally? And in our opinion, it can be changed, and also the key priority is how the interaction between the satellite operators or those companies who build the satellites and government is done. So in our view, it can be could be built as an e-service. And right now I'm writing the law and also finding the way how to set up this kind of e-service which could make exchange of information then between the satellite operators and governments a lot more easier, and hopefully also lower the cost for the parties. And our view on the space traffic management is that it's all about trust and communication. There are many similarities with the e-government that Estonia has already developed in the past decades. And e-service would make satellite registration easier and enable a streamlined communication among all parties. So it is something that we can hopefully then build the first minimal viable product to really showcase how Estonia maybe can even help to solve a global challenge in the next years. So I think it was the last slide. Yes, thank you. And if you have any questions, then I'm all yours.
Thank you, Paul. I think that now if we have time for further question. By the way, thank you very much for presenting the Estonian e-governance model and the Estonian competencies and capacities in the fields of cybersecurity, artificial intelligence, and other innovation technologies, and showing how they can contribute to improve the resilience of the European space infrastructure and systems, including space traffic management and space cyber security. So I would move to the next speaker. Veronica La Regina is with us. Welcome, Veronica. Veronica has a vast academic background in electronic engineering and economics. Before joining Nanoracks, she represents today. She was a strategy and business development officer at RIA, working with the European Space Agency, as a business innovation expert of the Commercial Partnership Initiative for Space Exploration of the Directorate of Human Spaceflight and Robotic Exploration, as well as she worked for the European Space Policy Institute in Vienna, the International Space University in Strasbourg, and at Telespazio in Rome. Currently, she's Director of Global Engagement at Nanoracks, and Veronica loves when knowledge and business get together to push innovation for the benefit of humankind. So, Veronica, we're glad you are with us and very keen to hear from you.
Hello, good evening, and maybe people are sitting around the global clock. Maybe someone is saying good morning. So I'm very happy to share with you the thoughts from Nanorack Europe about these interesting topics about space and resilience. So I just try to prepare in order to share the visuals. I hope everything is going on. So good afternoon. So thank you for considering the voice of Nanorack Europe for this interesting panel and discussion of this event. And we would like to put on the table our experience in Nanorack as a space station company. We, since the beginning, we understood that actually accessing space is something that unlocks potential to solve terrestrial challenge. So we see that the difficulties of surviving and performing activity in space is a very good lab in order to improve life on Earth. And at the same time, we would like to advance humans to Moon and to Mars. So having this in mind, we are on the market since more than 10 years, and we have been serving customer base all over the globe, over 34 nations, and sending up payload not only for, let's say, just space purpose, but particularly for improving terrestrial condition, encompassing the challenge of scientific fields like life science and material science at large. So what's going on? What's happening in Europe? We know very well that let's say the last month there has been the issue of the Massimiliano's manifest. So there has been this intermediate ministerial meeting at TAS-I, and they came with a very comprehensive program introducing the new type of policy mechanism like accelerator and inspirator. A number of these elements, policy elements, they focus the attention on the key topics of resilience. So how space can be basically a resilient capability when a shock, a crisis is happening. Well, this is very, very important. And what we have been particularly appreciate is the fact that through the documentation that has been released from this ministerial meeting, we see that there is a shift of paradigm that is much in line with our mission, that we would like to be commercial-driven company, and we would like to unlock space for the benefit of everyone. Indeed, in this documentation, we see that the agency is moving from an agency-centric approach to a more commercial-driven path. So basically, this makes us very comfortable, and we would like to play a role in this new frame. I think most of you, they know NanoRack, thinking about nano, small payload, and the release of CubeSat. It's true that participation from a large number of newcomers starts with a small dimension. Indeed, we have been enlarging the capability of facility, our own proprietary facility on the ISS, for instance, with the Bishop. The Bishop is actually a tangible, large infrastructure, quite complex, enabling the transfer of the payload, but also the hosting of the payload, internal, external. And the ambition is not set there because now it's already operational since 1 year. Our ambition now is to move to a commercial station. Well, why this happened? Why a number of actors, where NanoRack is a prime, and then we are backed by the financial capability of Voyager and the manufacturer and the large system integrator of Lockheed, we would like to have our open space commercial station. There is a policy condition that is the NASA commercial layout destination. There is upcoming new policy element just recently issued by ESA looking at commercially for a new infrastructure or the way to perform space activity in orbit, the SHE-Hub. So also ESA is looking for end-to-end services in LEO. And we know that at the same stage, the ISS, this beautiful intergovernmental landscape, enabling a number of activity, and the hardware is getting closer to be renewed, to be renovated. So in a certain way, we need to be resilient to the aging of the station with something new that is able to enlarge the capability of accessing space. And we do believe, we are really a believer that space is unique because it's offering you a number of opportunities. When you reach space, actually you have at least 5 stressors, like the one they are listed in this visual, the differentiated gravity experience from hypergravity through the launch experience up to the reaching the LEO, where you have microgravity, you have exposure to radiation, exposure to unusual physical condition for pressure, you are in a condition of isolation, confinement, the scarcity of resource, and then you need to challenge the extreme hot and extreme cold. So if you put something at the exposure of at least 5 stressors, something needs to be resilient. When it's resilient, it means that it's resistant. So basically it's introducing an innovation. That's why I am happy to share with you here a list that is not exhaustive of our innovators. Basically, our innovators are our customers around the world that challenge our capability to perform their activity. Their activity, basically, they benefit of the space environment. They benefit of all these stressors to improve the potential of their technology and the understanding of the scientific objective. So the will now at NanoRack is to come up with a Star Lab. It's a very ambitious program. We would like to have this open commercial low Earth orbit destination with a number of key figures, because it's going to be continuously crewed with people on board, astronaut, powered, operational, and also starting from initial configuration is looking for partnership for a large. So we would like the pleasure to enlarge the participation, not only in terms of customer base, but also in terms of trades and manufacturing and providing of the system and technology. So it is an opportunity to be really with an asset in orbit, in order to be responsive to the aging of the International Space Station. So basically, in summation, for everything we have discussed as a NANORAC, as a private sector, we have been a sort of pathfinder. We came with the NANORACs, and now we come after 10 years with the idea to have a station. I think each step from the small capability to the large one has the goal to unlock space accessible to everyone. And we believe that the commercial-driven approach, it is one of the potential and one of the best way to unlock this. So basically, if industry has the role of driving innovation, we're looking forward to have a space agency responsive in order to assure a resilient framework in case of shock crisis, as the one that we are living today in terms of climate change, in terms of pandemics, in terms of leakage of industrial element, technology element, and so on. So basically, being a believer that space is enabled for growth and progress, we believe that all the community shall internalize the benefit come from space utilization. So basically, if you do something in space, you are getting an understanding in order to improve also your terrestrial challenge. Having this in mind, I shorted my talk, and I am very happy and open to any question, if any.
Very good. Thank you, Veronica, for saving us some time. I mean, you may understand how much I appreciate your presentation, knowing that the Italian Space Agency have worked for 15 years to the International Space Station program, either to the development and the utilization. So if I was to try to recap your contribution today, I would list the following highlights. Space enables scientific and technological progress, and therefore forges a resilient capacity of humankind. The increasing number of space actors and the increase in the use of the outer space requires reflections and supporting actions for enabling the full potential of commercialization and competition while ensuring the sustainability of that growth. And the institutions have a role there. They have to support the changes on one side, and on the other side, they have to challenge the European industry to, let's say, walk alone with the commercial perspective, and this will allow to expand the distribution of benefits, opportunities, and to make space more accessible to all at sustainable condition. And thank you very much, Veronica, for addressing resilience for those multiple perspectives. I think that we may have a couple of minutes yet. I will ask you a question if
sure,
permit. I mean, I was impressed of your plan on Starlab. What major impact does NANORAC expect from Starlab?
Well, we have the ambition to have many impacts. The one that I would like to share with you, it is that we will come with something enabling an ecosystem that can satisfy the request that someone call and say, by tomorrow, I would like to bring something up to Starlab at this price where I can come. So basically, we would like to make space closer to everyone, because one of the challenges nowadays, the logistic to approach space and to prepare the readiness to fly. So we believe that we have enough experience and beautiful partners, and also the opportunity to work with many space agencies and public institutions around the globe for making this happen and create an ecosystem that speed the path to space.
Very good, Regina. Thank you. Thank you for being with us. And I guess we move now to another view from a new space company quite solid one. We have with us Rafał Modrzewski, CEO of ESI. Good afternoon, Rafał. Rafał is the CEO, the Chief Executive Officer and co-founder of the ESI company, which is the owner and the operator of the world's largest constellation of synthetic aperture radar satellites. And since co-founding the project in 2012, that became the company in 2014 with Pekka Laurila, Rafał is responsible for overseeing the organization growth and implementing ESI overall vision. And he can bring to the company his deep expertise in SAR engineering. And in 2018, he received the Forbes 30 Under 30 Technology Award based on the UN Sustainable Development Goals. So, Rafał, thank you for being with us, and the floor is yours.
Thank you. Thank you very much. Thank you for having me. Let me just share the materials. Wonderful. I believe you can see them now. Good morning, good afternoon, and good evening, depending on where you are. I am very happy to be here with you, and will be glad to walk you through a little bit of the history and what ESI really is, but more importantly, how do I believe Earth observation and related technologies can contribute to the overall resilience and sustainability, and especially from ESI's perspective, we are focused on the natural catastrophe area or domain, and I would be very happy to show you the progress that we've done and what generally the new space can offer in that domain. So I like to start always with a bit of maybe a thesis statement or just a thought process. I am a believer that this is really what's happening around us, and what is this thing that's happening. So if you were to observe the type of activities that different companies embark on, they very often have one thing in common, and that thing that they have in common is sensor technology. So the companies, whether from Europe, from the United States, or other part of the world, deploy different type of sensors, whether through International Space Station like NanoRacks or ESI with its satellites, SAR satellites. But we also see companies deploying drones, companies deploying ground-based sensors. All of those sensors really come together in what we very often call a real-time world monitoring ecosystem. It's really about bringing data together that can help us understand the world around us in as real time as possible. And if we can utilize that data for decision making, then that decision making becomes much more efficient, becomes faster, and very often automated. And the hope is that we can use that data to help decision making, especially related to resilience and sustainability. A few more words about ESI itself. It has been very nicely introduced, so thank you very much for that. I think there's few metrics I always like to give. We have launched so far 14 SAR satellites. The satellites are designed by a team over here in our offices. We build them also over here. We then source a launch capability, and then we launch them. We do have quite ambitious plans for next year. We want to launch 10 more satellites. We generally build about 10 to 12 satellites a year. There's about 400 of us. This may not always be known, but I feel like it gives a sense of the size of the company. And the company, as many of the new space companies, is financed through private investment, and specifically for us, it's a combination of Silicon Valley based as well as European investors. Now, as I mentioned that we build the satellites, I often like to bring the actual picture of those. Those are 4 satellites that we have launched around summer last year with our fearless assembly AIT team that has put them together. And I'm happy to say that all 4 of those have been very successfully placed in space. And I actually even brought a video for us over here to to take a look. I'm not sure how many of you have actually seen a satellite being deployed from rocket. Nowadays, it's become the service of launching has become commoditized enough so that with that service comes a live video feed. So whenever we launch our satellite, this video feed is being watched by all ICIers, and we can track our satellites. And so we have this small recording over here that shows the ICI satellite is the one on the top left part, and that was one of the 4 that we have deployed. This is a Falcon 9 rocket that we've launched around the summer this year, and of course that's always a huge moment for us whenever we see that. Let me just jump through the video. So, I guess one of the important things to know about ICI satellites, I often refer to them as SAR satellites. That really stands for a synthetic aperture radar, or one can think of it as an imaging radar. It is an imaging instrument. So an instrument that after the data is appropriately processed, provides an image of what's happening on the ground. That image is somewhat similar to an optical image. That's why we refer to it as an image. But as it uses radio waves, which it generates by itself on board, it can image regardless of weather condition or time of day. The resilience related to weather conditions is really linked to the wavelength, and the fact that we can take images during the night is linked directly to the fact that we have to generate our own energy. And this is also why this instrument tends to be more complicated than others. It needs to be both extremely sensitive in order to receive very weak signals that are bouncing back from the ground, but it also have to be very powerful at the same time, as it needs to generate all the energy that needs to travel from the satellite to the ground and then bounce back. As an advantage, which basically what it gets compensated for this complexity is we can see through clouds and darkness. Now, I wanted actually to share this with you since I took advantage a little bit of the moment that I can speak today. This is our today's announcement. We are continuously working with an ICI. We have a team of experts that is always trying to push the boundaries of what's possible with small satellites. And we are quite known to release world's first. Actually, ICI has launched the first small SAR satellite in January 2018. We have followed further with the first satellite to reach 1 by 1 meter accuracy. Then we have followed with the first small SAR satellite to achieve a scan-SAR capability. And just now we have patented actually a new type of imaging technology, which is called generalized stop SAR. It gets very technical, but it allows us to broaden the swath within the size of the frame quite substantially. So on the left side, you can see our old imaging capability, which is 1 by 1 meter spotlight mode. On the right side, you can see our new imaging capability, which is a 15 by 15 kilometers 1 by 1 meter spotlight mode, which is an order of magnitude larger in terms of the area coverage, which also means that it's an order of magnitude larger in terms of the data that's being collected, and ultimately that obviously is what we care for. And for those of you who are trying to recognize, this is Paris that we are looking at. And so now a little bit to the sustainable goals. ICI's name, as some of you may know, really derives itself from imaging ice. Eye on ice, or ice and eye, were really the two words that we combined. The founders have combined in order to create the name of ICI. The relation is not circumstantial. I mean, we did want to launch those satellites in order to help gather more information about the Arctic ice, in order to support the goal number 13, which is the climate action. So to fight the climate change. Now, among those 17 goals, we believe that there is 6 which we can particularly impact and influence. And I will try to walk you through examples of how we can actually improve the life on Earth through the use of our technology. Maybe before I get there, I wanted to walk you through just 4 key attributes. I think what very often is not looked at is what is the combination of features that a SAR satellite constellation really can offer. What's the type of unique data set that we can generate? You know, I always think of sensor platform modalities so as tools, and so each tool as we have them in our toolbox has a specific use. You know, we use hammer to hammer the nails, we use screwdriver to open and close screws, and so a synthetic aperture radar SAR constellation is basically one of those tools. It has a very specific data set which has unique characteristics. Now, what are those characteristics? First of all, it's a global data set, and that's very important from the sustainability perspective, because that means that we can address problems regardless of where they are located from in the perspective of our planet. So that's provided by the fact that we use satellites. Second, it's a very high speed or very fast response data set. Not instead of owning one satellite, SAR satellite, ICEYE owns 14. Soon ICEYE will own 20 and 20 plus satellites. That means that we are an order of magnitude more frequent, or an order of magnitude better response that we have than what we used to be able to generate from comparable systems. And we measure now our response time in a matter of hours. I will show you a set of examples, but whenever there is a need for us to image any place around the globe, we can get to that place within 2 to 3 hours and take that image and analyze what's happening on the ground. So not only we have global access, but that global access is actually very rapid. The third one, which we've already touched on, is our ability to see through clouds and darkness. That is a great combination with the rapid access, because that means that not only we can get to that place that we want to be at, but we can also image it regardless of time of day or weather conditions situation over there, which means that we can really respond quickly to an emergency that's happening somewhere. And last but not least, we can image very large areas simultaneously. I mentioned that we have released the ScanSAR capability that actually allows us to image over here. We are looking at one of the emergencies that we've covered. This is the Suez Canal and the evergreen ship stuck over there. We were able to both see the ship itself and all the activity around the ship, but we were also able to see the entire Suez Canal with an image which is over 300 kilometers long. Now, what do we do this? So live below water, we are actively working with European as well as international players to capture oil spills, track those oil spills, and make sure that we respond both in terms of emergency response, but also from the perspective of law enforcement. So this is a real oil spill that we've tracked, and we have tens of those oil spills that we have tracked so far. And as you can imagine, speed of access is here key. Oil spills really happen anywhere around the globe. You want to be there as fast as you can in order to respond, and you have to see through the darkness, because they can happen at any given time. The tendency is also that the area that you need to monitor is very large, and this ScanSAR obviously helps here dramatically. Next, we have illegal fishing or just sustainable fishing. As we know, fish and the whole ocean food supply is critical to many countries and many societies. Overfishing is a very dangerous method of dealing with that, which is why we need to be able to control the fishing quotas, something that the European Union has been doing for quite some time and very effectively tries to enforce. And we need to find the right tools, the right information mechanisms to be able to help them. Combination of synthetic aperture radar imagery with something which is called AIS allows us to identify what we refer to as dark vessels, and those dark vessels are the type of vessels that do not want to or should not be within that area. Then further, we look at the agriculture. We can use synthetic aperture radar to monitor quite a large area, and we can help both enforce the different agricultural things, as well as help advise farmers on how to farm in the most sustainable and reliable way. We can look at the urban development. This is actually one of the new products that ICEYE has developed, which is called a daily coherent change detection. It allows us to see the same area with geometry every single time with the same geometry, allowing us to measure things like amount of vessels coming into the harbor, amount of cargo being left in the harbor, amount of cargo being transported on the train, amount of oil being stored. generally helps us with monitoring of the global supply chain, which has been recently so heavily impacted, as well as it helps us understand what's the best way to grow our harbors, our supply chain nodes, and the urban areas altogether. One of the initiatives that we're extremely proud of and very strongly linked to sustainable goals of the UN is monitoring deforestation. You can see actually the illegal logging happening in this particular area. We work here with a set of governments very closely. This is a SAR image in the coherent daily GTR capability, which very clearly shows disappearing forest area. And I'm proud to say that right now we are actually monitoring a very large area of forest and daily producing reports on illegal logging. We work very closely with infrastructure monitoring capability. We have an ability to help, currently not yet fully prevent, but we are working on this. There is a lot that can be done in the infrastructure monitoring, whether that's around dams, bridges, buildings themselves. It's very often referred to as an interferometry capability or point scatter interferometry. Once monitored very frequently, it can really give us signals of what's happening before it's about to really take place. And that's under goal number 11, sustainable cities and communities. We really want to make sure that the urban development is both quick, but also most importantly, safe. And last but not least, from our side, we really are putting a lot of effort right now, as you can imagine, to the natural catastrophes. The first natural catastrophe that we've decided to tackle is the flooding. This is one of the pictures that has made press around the world, and I will show you some of the examples. But it is really, this is the Bahamas that have been hit by the Hurricane Ida. And a large portion of that area has been flooded, and for a long time, no other sensor by ICEYE space-based sensor was able to penetrate through the cloud cover and really uncover the ability of flooded area. Now, in order to solve the flooding problem, we cannot just take SAR imagery. SAR imagery is extremely helpful over here, but I do want to point out that ICEYE doesn't just launch satellites and then take SAR imagery. We actually have to merge it with about 8 different data layers in order to create the ultimate output, which is the flood depth and extent. So this is the type of products that we would be generating for the government. This is the type of product that we will be generating for the emergency agencies on the ground in order to help immediately respond in the most accurate and efficient way to a disaster at hand. So right now we are very heavily involved in flood monitoring, but we are working on hurricanes and wildfire, basically following a little bit of what's happening around us, and the nature really gives us the very quick input on the product development roadmap on our side. And we really hope that our team can crack the code on those 2 additional disasters as soon as possible. Thus we can provide the communities with a more resilient capabilities over the next year's season. This is a natural consequence of the climate change. Of course, I wish we were able to prevent the changes as such, but right now I think it's fair that what we want to do and what space can immediately help with is to relieve some of the consequences. And indeed, this has been of help to many communities. Most recently, we've covered the flooding in British Columbia, and as you can see, we're actually quite actively doing this. The Bahamas picture, as I mentioned, has really made it around the globe, and has been shown in CNN a few times, and New York Times is a frequent publisher of our imagery. As actually all the media outlets that care for the relief of human suffering during natural catastrophes tend to release the data, and we are very happy to share them as well, because at the end of the day, that's what this data should be used for. So that's ICEYE's mission. That's how we perceive our sustainable our mission in fulfilling the sustainable goals. I want to say that I believe that we are at the early stage of this journey. It may seem like we've done a ton. We have 14 satellites. We've covered probably over 100 floods over this year and last year. The truth is that we are at the very early stage. Even in the floods, there is still a lot that we can learn. And I can't wait to show you next time the wildfire and wind damage capabilities and really all the other things to come. It is truly exciting times for space community, and I really am a believer of the fact that new space can bring valuable data for decision making in this time when we really have to answer problems that we haven't really had to face before. Thank you very much.
Thank you, Rafal. Great presentation. Thank you for presenting EYESI mission, SAR technologies, and how your company's technologies and use cases can largely contribute to resilience on Earth and to face societal challenges, and specifically the UN Sustainable Development Goals. And we appreciated much the EYESI solution on flood monitoring. That's great. I mean, it's very clear how new space company can provide their contribution. I wonder what your and you are looking to the market. You are commercially driven. I wonder what your expectation from institutions. How can institutions help to improve your resilience with respect to your external world, meaning competition and market?
Right, and so of course I think it's challenging to answer this question with a single sentence. I mean, if I had to answer it with one word, I would say cooperation. The more cooperation there is between the public and private institutions, the better for both. I think one of the brightest example of successful collaboration of private and public kind of institutions is Copernicus program and Copernicus contributing missions, right? So we have the Sentinel program with Sentinel satellites, and they fulfill a very important mission of continuously mapping the entire globe, right? I'm very happy to say, this would be currently impossible to achieve through EYESI constellation because it hasn't been built for mapping capabilities as such, right? Now, on the other hand, the Sentinel satellites, as there is one source satellite, is not able to respond as quickly as EYESI's constellation, nor can it respond with the same accuracy as EYESI's constellation can. Now, that means that those two data sources are highly complementary, and we use both of those data sources in our flat solution. And so we see that there is a place to play for the institutions, and there is a place to play for the commercial market. I think what ESA's strategy has been to refer to just in the previous presentation. I do believe that that's the direction that ESA is moving towards. We are starting to see that the industries Europe has matured enough so that we can actually involve and present some of those problems to the industry. And as long as the institutions, which I believe are actually fine with handing some of those challenges over to the private sector, will do that, then honestly we will have the winning combination. But the more we can talk and discuss on who should take which part of the challenge, the better it will be for everybody.
Very good. Thank you, Rafael. Thank you also for bringing up the importance of cooperation and complementarity. All right, then I guess there is not much left for today. Rafael Morgiewski's presentation was the last one for the resilience session of the New Space Economy Conference, and we heard from institutions, established companies, and new space companies their views on resilience in its multiple dimensions and how they can contribute to reinforce the resilience of the space sector, of our societies and economy, and ultimately of the humankind at full. I think that we can conclude here the session. Let me thank again the panelists, the organizers, and of course the audience who have followed the session. Have a nice evening, you all. Thank you.